تفضلوا يا أخوان، بدنا نبدأ لو سمحتوا.
السيدات والسادة الكرام، أسعد الله صباحكم. نود أن نلفت انتباهكم إلى أن خدمة الترجمة الفورية من العربية إلى الإنجليزية ومن الإنجليزية إلى العربية نأمل منكم الحصول على أجهزة الاستماع إلى الترجمة عند مدخل هذه القاعة. Ladies and gentlemen, please note that simultaneous interpretation headsets are available at the entrance of this hall. This event will be interpreted from Arabic into English and from English into Arabic. نأمل منكم التفضل بالجلوس على مقاعدكم استعدادا للبدء. Please take your seats. We're starting shortly.
يحيى.
السلام الملكي. Please rise for the Saudi national anthem.
اليوم أنا الوحيد رح أحكي عربي، فحبيت كلمتي تكون بالفصحى وبعدها حقدم جاك. من جمال اللغة العربية قولهم: إذا ما نزلت بأرضهم فأرضهم، وإذا ما نزلت بدارهم فدارهم، وإن ما نزلت بحيهم فحيهم. حياكم الله والسلام عليكم ورحمة الله وبركاته. أصحاب المعالي والسعادة والسيادة الحضور الكرام، شركاء أزري في المملكة، صباح الخير من الرياض الغالية، وأهلا وسهلا بكم في مؤتمر مستخدمي أزري الأول في المملكة العربية السعودية، طبعا لن يكون الأخير. يقول جاك دانجرموند إن نظم المعلومات الجغرافية هي التكنولوجيا الوحيدة التي تدمج فعلياً العديد من الموضوعات المختلفة باستخدام الجغرافيا كإطار مشترك لها. أيها الأصدقاء، كما تمنيتم دائماً، ها نحن اليوم أقرب إليكم. أزري اليوم في الرياض في خدمة شركائها، في خدمتكم جميعاً. 10 سنوات من الجهد والمتابعة مع فريق عمل فعال رغم تواضعه، نسعى جاهدين للعمل ودعم بيئة نظم المعلومات الجغرافية في المملكة. أما مع انبثاق رؤية 2030 وانطلاق المشاريع التنموية المترامية الأطراف والمبادرات الهادفة للتطوير، فقد رأت أزري في انتقال عملها المباشر إلى المملكة من دون تمثيل محلي أمراً استراتيجياً وواجباً عليها. كما واستجابة لسعي المملكة العربية السعودية إلى تحويل الرياض مركزاً إقليمياً للاستثمار والأعمال، بادرت أزري إلى تأسيس شركة جديدة، شركة أزري العربية، لكي تكون مقراً إقليمياً جديداً في المنطقة من الرياض، نعم، بحيث تكون أقرب في متابعة عملياتها من أي مكان آخر. لن أطيل الكلام، الكل في انتظار جاك، وجاك طواق للقائكم جميعاً. Let me have the pleasure and honor to invite Jack joining me on stage.
Thank you, Tawfiq. My great pleasure. Thank you. Ladies and gentlemen, it's my great pleasure to welcome you to our very first user conference here in the Kingdom. This all started over 35 years ago. I'll tell some of that history a little bit later, but it's my great pleasure on behalf of all of my colleagues at Esri around the world to say thank you for coming and welcome to this very special meeting. The purpose of this meeting is quite simple, actually. It's for us to be together, to share and learn. I'll be covering a lot on the technology. I suppose that's why many of you came. What's new? What's the latest? But I want to let you know that inside of this room represents great amounts of knowledge that you, as GIS professionals or familiar with GIS, have that I want you to share. Learn from each other, building community, building a kind of connection between us. I haven't been here for over 3 years, and right away I'm inspired by just seeing old friends and reacquainting and catching up. You know, it's fun to catch up on the news. In many ways, we'll be catching up on the news not just from Esri, but from each other in this special meeting. I want to start the meeting also by having a few comments about who you are. I mean, already I've seen old friends, people that I've known for decades, and that's very special to me. But this is a special audience because you come from different disciplines, different backgrounds, some in the academy, some in business, some in government, local government, national government. All of it is in this room. Representations almost of every sector of the kingdom's society. This is interesting to me because you are all using, familiar with, working with this one vision of geographic information systems making a difference here. Well, before I go on to the work, I want you to actually experience what I'm experiencing by all standing up, if you could do that, and introduce yourself to one new person and let them know who you are and let them tell you the same to you. So could you do that for me now? Stand up and introduce yourself to another person and tell them why you're here. Meet a new friend. Good. That's good. Very good. Thank you. It's perfect. Excellent. Good work. Okay, sit down. Let's go. I hope you're getting a sense. I hope you're getting a sense of the richness of this room. You are diverse, you have big backgrounds, and you're working on very important work. And I'm hoping that this first conference that we hold is the beginning of enriching the GIS community long into the future. I want you to get to know each other, and one way to get to know each other is to understand each other's work. So some of you have shared with me and optimizing it, like is going on here with Masa, looking at how to manage the assets, how to do utility management, regulatory compliance. This is fundamental to the system of record of GIS. And more recently, in the lower left, we see the integration of BIM information, so whole sewer plants right into the network. But whether it be sewer operations in real time or monitoring water consumption by population, GIS is exploding actually in this field of engineering applications. Need I say that utilities are systematically being transformed with GIS? Again, all operations from the field to asset management. Here in the kingdom, the electricity organization completely dominates across the entire kingdom with these applications, real-time monitoring for executives, but all the way down into the field with field data collection and monitoring. And in telecommunications, similarly, we see applications of broadband availability, looking at the digital divide in the kingdom. And this again is going on repeated in most countries around the world, making society more accessible using telecommunications. GIS has long been credited with saving people's lives and making society safer. And this starts by observing crime in police departments, managing fire departments and their dispatch access. It also deals with events, for example, like the big race here, the sort of unified command and control center to look at the speedway from time to time. Isn't that interesting? I mean, to me, it's exciting. Planning and responding to disasters is another field, particularly with climate change, flooding, sea level rise. These are big issues that we're going to be challenged with increasingly. And in the upper left, notice the emergency response mapping, drive times away from remote centers and showing the coverage of that. A couple years ago, almost universally around the world, census was taken. And in my country, this involved enumeration. GIS was the foundation for it. But in the kingdom, the national census was not only collected using the fabric of geography, but also mapped and reported in various ways. This is happening not just here, but in developing countries and very sophisticated countries. We see in the lower right the work that was going on down in Africa, where the GIS was the foundation for enumeration and then reporting. You and I are coming out of this horrific, crazy time of COVID. And here in the kingdom, GIS played a major part with the Ministry of Health reporting what was going on occasionally. Globally, it opened people's eyes to see this terrible pandemic starting in China, moving out, affecting and killing millions of people. But GIS, I would say, is credited with being able to make people aware of the pandemic and then respond effectively. Vaccination reporting, being able to do, well, not just COVID, but look in Pakistan, for example, they're trying to get polio in the box and stop it. This is a major effort by organizations like WHO and also local health organizations. Imagery, remote sensing, has become part of GIS. It's no longer a separate activity. And these examples show wonderful work on urban planning, for example, in Mecca using latest imagery, or land cover change in Nigeria, or we're seeing also in the field of utilities like electrical utilities, the use of LiDAR, being able to see what you normally wouldn't see by your eyes. Remote sensing is taking off. Even from satellites, we're seeing now illegal fishing in the right here around the kingdom. All these examples are profound, actually. I'd like to start off our users meeting by having you see some of your own work. The great work on building the national spatial data infrastructure that's going on by GASCI is interesting. I can't share with you all of the work that they're doing, but they will be talking about it after I finish my speech. It's extraordinary because it's about opening up data. It's about sharing GIS services not only between and among organizations, but also increasingly with the public engagement. The world is changing, actually, and GIS is helping some of that change. I'll call your attention to the two slides in the upper right. This is in my country. Two organizations, one, the Red Cross, and the other one, our National Emergency Organization, sharing information about hurricanes and responding to the disasters that happen increasingly with nature. Opening up GIS, letting it be available for public engagement is amazing. Well, all of these examples are worth mentioning. We could spend the whole day here, and there'll be sessions where some of you share some of your work over the next day or so. But I want to move on to the second part of my presentation, which is, where is this going? Where is this going? So I want to present both a vision for GIS, how I see it playing with society, because we're all involved in it, and what it actually ultimately means in the world. I'm going to use the words mapping common ground. This is about creating agreed upon understanding. I'll come back to that phrase a few times. Our world, where we live, is complex, both on the human side, but also on the natural side. We're beginning to see the world as an integrated, highly interdependent ecosystem. It's one way to look at our world. It's fragile. It's increasingly losing biodiversity, but it's rich in biodiversity. It's not actually well known. I mean, we often think of the world as being known. I know the world. But actually, it's not well known. The processes, the connections, they're alive, we know this, but it's not well known. And at the beginning of this conference, it's useful just to acknowledge it, that we live in a living world that's changing very rapidly. When I started Esri, the population of the world was about 1/3 of what it is today. It's exponentially growing. We're seeing the huge wealth around the world impact the natural environment. Our world is increasingly dominated by us, the human species. And this is creating challenges. Humans, in many ways, are living recklessly and not understanding the impact that we're creating. One might say it's out of balance with nature. And this is creating some conflicts in our world with climate. We hear about this all the time. With the impact on water and on biodiversity, we're seeing it impact our societies in general. And we're all part of it. This is ultimately changing our sustainability. When I work and see some of the work going on at a global level, I realize we all have to begin to not only understand it like we came to understand the pandemic of COVID, but also, hold on just a minute, but also take responsibility for participating in it. Thank you. I'm really technically able to fix it myself, but it feels good that somebody is helping me, actually. You understand this, right? I spend a lot of my time thinking about this, and I'm sure you do as well, and your friends and your family and your communities and the organizations that you work in. And when we get down to it, the central problem of our time is the lack of understanding. One of my best friends says, "Jack, you're not in the technology business, you're in the understanding business." The central problem of our time is the lack of agreed upon understanding and also our failure to collaborate on these big problems. And this central problem is what I think is our calling as GIS professionals. Mapping and the geographic approach are powerful means for creating understanding. You know this in your work, for exploring alternatives and finding solutions and reaching agreement, finding common ground, mapping common ground. It's a kind of foundation for positive action. Now, this mapping that we work with is a kind of fundamental language. It started about 6,000 years ago, not very far from where we're standing today, with basic graphics, hieroglyphics, graphic expressions, and it advanced civilization. It kind of co-evolved with civilization itself. It's helping us always understand and collaborate. That's one of its great powers. Mapping both what is and also what could be. Sketching. Let's go here. Let's explore there. Let's make a land use plan like this, built on fundamental understanding. And today, with the kind of technology that we have, this is accelerating. It's accelerating our civilization, actually, linking science to human action. Now, I like to say that this mapping common ground requires that we consider all the factors, not just economic factors or environmental factors or even just social factors, but geography, the science of our world, brings all the factors together. This integration is what's missing in so much of our work, because by integrating geographic information, we can see things. We can see the complexity of our world and drive this vision of better understanding. I like to call this the geographic approach. It's a way of thinking, the geographic approach. It's a way of acting, the geographic approach. Let's take the geographic approach. And whether it's Starbucks locating restaurants or finding nature reserves or doing land use, the geographic approach. It allows us to be holistic and bring everything together and integrate our knowledge and collaborate across different organizations. This is the huge power of GIS. It's not just integrating data, but it's integrating collaboration among us and between us. And my assertion is this will ultimately impact virtually everything humans do. It's a foundation infrastructure. It's why this meeting is so very important. GIS enables this kind of thinking. It's a new generation, actually. It's a process of data collection and mapping and analytics and then planning that drives decision-making and action. And while many of you don't see your life in this process diagram, I see it there. Some of you are just making maps. Some of you are doing analytics. Some of you are doing planning. But GIS has got this huge benefit of bringing it together. And this GIS and the geographic approach, I think, are fundamental for finding solutions for our future. You can glance through these pieces of text, designing green infrastructure and approaches, a big initiative of the Prince here in Saudi. But finding sustainable land use, dealing with biodiversity conservation, all of it. Mapping the future that we all want to see for ourselves and our family. You, particularly GIS professionals, are already doing this. Maybe you're not so conscious of it, but I see it. I see it in the footprints of your work. And whether it's working in rural communities in developing countries, or whether it's the UN with the SDGs, global sustainability goals, at all scales, this is about leveraging your profession, the technology, to be able to create solutions at many scales about creating a sustainable future. Now, GIS professionals, here I'm speaking to you, have an important responsibility in this regard. It's not just dealing with the technology. It's about facilitating this creation of common ground, seeing what's needed and wanted, and whether it's in Saudi Aramco, seeing what's needed and wanted, or whether it's in the housing, or whether it's in environment, seeing is a big part of it. And then supporting community engagement, because these problems are complex, we need to bring a community together. Or connecting the data to the science, to the actual application of making decisions. This is what you do. And enabling holistic approaches. This is the vision that's necessary to create a sustainable future. And thinking about it, it's about listening, not just talking. Listening, understanding what's being said, resolving conflicts, not in jealous environments, but collaborative environments, and then creating creative solutions. So the first part of my talk, I just wanted to share this vision because I think it's powerful. It's the thing that brings us together. It's why frankly, it's why I like the kingdom. Because I know you enough to know behind your own individual professional careers, this aspiration of creating wholeness is in your soul, and I appreciate it very much. Next, I'd like to talk a little bit about our work. This is Esri-centric. 54 years ago, we began our organization with this idea of building successful creative tools that could support others doing their work. We started actually doing work ourselves, but what we discovered is that it was a much more important mission to serve others by creating technology, educational materials, and then support to help them do their work better. This is our big vision. And the invention of ArcGIS, ArcInfo first, and ArcGIS has had this notion or vision of creating an enterprise platform capable of many implementations, the desktop or a server, or now from the cloud, with devices, mobile devices, all working together as an integrated system, easily integrated, and working for an individual or an organization, or organizations working together, sometimes referred to as SDI. The vision behind this technology was supporting three kinds of systems. The first one is a system of record. This is like land records, or forestry, or assets. Second, a system of analytics or insights. This is overlaying data, doing analytics with it. And third, a system of engagement, like through mapping and apps that engage people across the organization and across society. Sometimes these are referred to as databases and business intelligence, and also engagement systems. But ArcGIS is actually all three of them together in an integrated environment. And it has been designed to be open and interoperable with other technologies, database technologies, open source technologies. By using standards and also an open architecture, we've been able to integrate within the infrastructure between organizations, sharing with open data. And the evidence of that are the tens of thousands of enterprise systems that have been integrated into organizations successfully at all scales. This technology keeps advancing. Esri spends about 1/3 of its revenue on R&D. This is more like a research organization than it is a normal business. And with those funds, we support thousands of engineers who basically advance the science and the technology in these various areas. I know some of you are interested in one of these circles or another circle. There are teams that keep working on these individual systems, capabilities rather, but integrated into one system. That's the sort of logic behind this technology. This morning I chose just 12 of the big trends that are occurring in my field, These are being worked on by different teams, actually in different countries around the world, and then it comes together into the technology that we give you. You can glance through these. These are significant research development activities which co-evolve with the science and the applications of our users. They keep co-evolving, and this has been going on for 40 years. So your feedback with us, one of the reasons why it's very important that we get connected in this meeting and beyond directly with you, is to get feedback about how it's going. Now, how's it going? And you're very frank about telling me how's it going. You have a bug in your software over here. Oh, okay. So one of the reasons why I'm sharing this is that we can be connected and communicate directly about how's it going. And so let me share these quickly. First, big trend. GIS is becoming interconnected with web services. We have millions of users in desktops that do work on their desktop. We have hundreds of thousands of organizations that implement servers and set up whole enterprise systems. But a third new pattern is emerging. It's called a system of systems. And it's interconnecting the systems in individual agencies or organizations with web services for sharing information. So I no longer have to have all of the data in my database. I can bring in data from another organization with web services. This is a very powerful idea. So in many cities who have different departments, they're starting to serve each other with web services, layers of maps in planning, in cadastre, in water, in whatever. And together, their data is being unified with web maps. Wonderful. It means I don't have to repeat the data in one single database. I can build a system of systems. And this is indeed the vision of an SDI, the idea that all of us start sharing and serving each other, of course with necessary security and so forth protocols, so that together the organizations in this room build with services a kind of whole new GIS pattern. The key on making that happen, see if I can make this happen actually, is that the key to make that happen, well, I'll wait for the key. I'll first simply share, there are about 2 million users, I know this, that are now sharing and using each other's data on the planet. And that's interesting. It's this kind of planet-level system. And they're sharing millions of their services and data sets, a kind of huge library in the sky where we can call on the data and mash it up and build new applications. And the enabling technology for that is a web GIS portal. This is not the same kind of portal as we talked about in the 90s with metadata focus. This is a web GIS portal where this network, those little circles are different distributed servers, this network of servers are brought together through a sharing services portal where people can, for a particular topic, pull the data and bring it together. So the White House, President Biden, built such a portal for the US government by pulling NASA data, NOAA data, census data, USGS data, Department of Interior data together to support integrated support for dealing with climate for local government. He said, I want to take all the national science assets of America and make it available for local governments and planners to be able to use. And it's just been enormously successful. You see the diagram? So the diagram shows that there's a network of services that are registered in a portal that support particular missions. That portal took only about 6 weeks to bring together, not 6 years or $6 million. It just took a couple of people a few weeks. And another portal is being established today for environmental conservation, and another one for human health. And in other words, there's the base services network, and these portals can be very quickly brought together for particular missions. This is a new pattern of GIS. The wonders of web services also allow us to take different types of data, imagery data, 2D map data, point cloud data, CAD data, BIM data, tabular data, of course, or even text data, and serverize it, and then put it into a portal for use in various kinds of apps. This is a very, very fast-moving trend, and I know that some of you here in the kingdom are beginning to use this pattern. I think it might surprise you just how fast it will transform your community here. The second big trend is apps, of course, desktop apps, web apps, and mobile apps. These are becoming pervasive, like millions of apps for utilities or for citizen connection or for applications of all types. What's powering those fast apps are app builders, GIS-focused app builders that allow the data to be mashed up and create an app very quickly for the field or for citizens, whatever it is. I'm talking about an app that might be 2 hours in its making, and app builders are the way that this is happening. The third big trend I'll hit on is web maps, and I think all of you will simply say, "Oh, Jack, that's not a trend. I know web maps. I know web maps. Google Maps or Bing Maps or, ArcGIS maps, they're web maps." But I want to distinguish what's occurring. A new generation of browser-based, JavaScript-based apps are coming alive. And these apps are different. They're happening in the browser, hitting servers. And you'll see in the upper right, they're interactive maps. So I can look at very large amounts of data interactively. Zooming, panning, of course, but notice this data exploration of the census data here. And they're extremely fast. They don't cost anything. And it's just changing maps, interactive maps, real-time maps. I can see status and interact with it and explore data like a GIS analyst would have to do on their own in the past. The next, storytelling is part of this web map environment. This new app for telling stories around a map, putting text or photographs engaged with it, is changing the way that we tell stories. The President of the United States is told about his national security framework every morning at 7:30, and it's all done with web maps, with story maps. Tell a story about what's happening in Ukraine or what's happening in China or other places around the world, what's happening with diseases, what's happening with whatever. Stories are the basis of actually mapping, and it's extraordinary what we can actually put into these. Similarly, dashboards. People are building dashboards about everything in the user community, and I saw a lot of them here in the kingdom. The map in the lower left is the COVID dashboard by Johns Hopkins University. It's now been looked at 1.4 trillion times. So it's educated the world about what's going on, what's going on today. People looked at this like they looked at the newspaper every day. It's a whole new medium for getting across your work and connecting you with people that you serve. The fourth big trend is spatial analytics. And this is not new for GIS, but it's opening up and expanding beyond just GIS users to support data scientists. So GIS is not just for GIS professionals anymore. It's opening up with a variety of techniques and being made available for the entire IT community. Predictive modeling, visual analytics, graph analytics, AI. Last night somebody was saying, you know, the Prince really wants to be totally embracing AI and machine learning in the kingdom. Well, GIS is now bringing in these powerful tools and making our applications smarter, whether it's from remote sensing or whatever the means are. Big data, raster analytics in the cloud, these are all interesting trends. AI and machine learning particularly is not just for imagery, it's also for our vector maps, and it's also for text. I can extract from the text features using AI and machine learning tool and put them right into the GIS world. Geo-AI is what I refer to it as. In the world of data management, there's new data models emerging that handle very, very large databases, like the utility network with literally millions and millions of features, very responsive. And similarly in parcels, parcel fabric technology is a new model for smart data management in the cloud and elsewhere. I want to hit on number 6, which is ArcGIS Online is what it's called. But this is a world that sets a new pattern. You know, in ArcGIS Online, there's something called the Living Atlas, which has thousands of layers of ready-to-use data available freely for the entire planet. This doesn't cover all the layers, but what it shows is that users are beginning to build ready-to-use layers so they can use each other's data to build apps very quickly. Every day, billions of maps get made out of the Living Atlas, and it should be part of your portfolio. Of course, you have your own data, both in your own agency, but also within the kingdom. But this is becoming a new pattern. I can imagine a Living Atlas emerging here that serves all of you based on kingdom-specific data, authored, organized, and shared by your own organizations. Another trend is 3D. Am I going too fast? Is this okay? You know, some of you have worked with 3D GIS for years, but Esri is now building a new 3D data model for like 3D cities or 3D facilities. This means 3D feature layers with 3D services. It means the integration of BIM into a 3D city. It means, just like the 2D enterprise system, I see this 3D system of record being able to be maintained by web editors in one department, but used by all the departments. GIS is going with 3D systems of record. And this is complementing the idea that GIS is now integrating in all of those image processing and image analytics tools into it. So in a single system now, instead of buying a separate desktop or a separate server, ArcGIS actually has brought these worlds together for map production and analytics, for visualization, for automatic updating. And some of this is just a vision, but most of it is actually here today. Part of that trend is the integration of reality capture. Here I want to slow down and say, there's a new technology. Some people are calling this digital photogrammetry, but it takes aircraft data or drone data, pictures, hundreds of them or thousands of them or tens of thousands of them. It puts it into a processing engine called Shure and generates automatically true orthos, point clouds, 3D meshes, and digital terrain surfaces. I mean, this is kind of hard to believe until you actually experience it. So what I'd like to do is show you a few examples. This is Vienna, downtown Vienna. It was flown. A few days later, this model was built of Vienna and integrated in with vector data. This is the area where the UN is located there. You can see the city. And this is a 3D GIS, built both by traditional vector means, but also overlaid with a 3D picture, a 3D point cloud, actually. This is in Utrecht in the Netherlands, And it's this 3D picture integrated in with 3D BIM files to build a true digital twin of vector and raster data brought together. And in this case, you can see the progression of the construction of this building with BIM, as well as the 3D picture taken. And you can also get a vision of indoor GIS, which I'll talk about more in a moment. Cities are starting to bring this all together for many applications. Drone mapping is complementing this. So drones that process data in desktops and create those same 3D point clouds or 3D models or elevation models. But also, increasingly, users are flying their drone, putting the data into a cloud, sharing it, so that we have this 3D progression that's occurring within the GIS family. Building these 3D models is interesting, but also we're seeing new experiences emerge with game engines. Last year, we introduced a new technology which takes game engines that your kids play on, game engines like Unity and Unreal engines, and we connected it to the same GIS as an application. This is allowing, goggle visualization of the game, of the same GIS databases that you're making at different scales. And we have in this room pioneers that have pushed that kind of notion, and it's now becoming a commonplace for visualization and simulation, but also involvement of public so they can see more effectively. This is an example of Gothenburg. It's a 3D digital twin of the city, and you can see flying through in a game engine environment, real-time data of people moving, exploration of the buildings that are there, the same attribute information in the GIS, but seen in a different kind of experience. These kinds of experiences will be augmenting what people normally do, and it includes real-time sensor networks to be able to both visualize in real time, but also simulate in real time interaction between the different components of the city. And this goes beyond this. You can actually look at things like floods or simulations of, okay, my slide is not working here, but anyway. I keep, I think, screwing up here. I apologize. This looks like I went all the way back to the beginning, so forgive me. Yeah, okay. I'm not this awkward, really. Please believe me. Not so bad at cities. That's good, thank you. So you can see Gothenburg again. Just notice that this kind of visualization allows us to bring in special effects like fog or cloud or moving things. It allows us to interact with the same GISs in different ways. Here we see again reading through simulated environments. Sorry, this is still not playing. Excuse me. Maybe we should just move on. Okay. Gothenburg, still not showing. Sorry about that. Too bad, you're missing out on the show. I'm watching Gothenburg. It's really quite extraordinary. Why don't we just stay with this and we'll come back to it. But we still need to be able to display. Anyway, do you guys have any questions while we're waiting? Is this too much, actually? I just ask. I'm sharing with you a lot of development activities, and I know it's a lot to absorb in one moment because each one that you see probably causes you to think about how it might be applicable to your particular application. But for me, these are thrilling adventures because with each advance in the fundamental technology, I see a whole new wave of applications actually emerging. So yes. All right, well, why don't you turn to your neighbor and tell him what you think? Want to do that for a moment while we're trying to fix this AV problem? Do that for me. Turn to your neighbor and tell him something about what you just saw. That's good, thank you. Okay. Should you activate this? Hit activate right here. Just hit this button, activate. Can you just turn the display off? Turn it back on?
I will call on a break now and you return whenever they fix it. That's okay? Better?
No.
Not to wait? All right, I'm sorry. Excuse me. Good. Stop talking. Put it on present. Good. I'm not going to go back and show you the game engine again, but let's talk about number 10. Okay? Shh, quiet, stop talking. Number 10 trend is that GIS as a concept and technology is going indoors. This means that people are building for their main campuses or their main buildings the same kind of databases that they did for outside landscape. It's like bringing your GIS indoors for room space planning, occupant experiences, finding your way through complex buildings, and so forth. Now, some of you might be interested that CERN, this is the big research laboratory in Switzerland that has the nuclear accelerator under the ground, has completely automated their entire facilities. Their campus, all the buildings now are smart, and also underground, the big ring nuclear accelerator is also completely in a GIS. This means they can link photos to it and move this thing around. It's quite extraordinary. They're also doing space planning. This is an example where a security wall has been set up protecting a IT facility. So you have to have a certain name card or badge to be able to get into a special room. They're using also for room hoteling. Right now, with people still working from home, they want to book a room in their facility, and this is all being managed actually in a GIS. Trend number 11 is that users are increasingly leveraging cloud computing. They're both putting their GIS in the cloud, like an Amazon or Microsoft Cloud, but they're also increasingly leveraging SaaS, like ArcGIS Online, in various ways, leveraging the Living Atlas, making it part of their actual system. And the final big trend is that GIS is opening up for community engagement and also engagement between one agency and another agency. I showed you a few examples of that earlier, even happening here in the kingdom. Okay. Let me conclude with just a couple comments about Esri. It is 54 years old this year. Its main mission, mission for all of these decades has been about serving our users. Our core business activities are about advancing the science of where, geography, and GIS itself. We are very engineering focused on our software development, and it's a strong and growing force around the world. It has about 10 million users, about 2 million of them are online. They use all aspects of our technology, and they collaborate, much like we're collaborating here, in bringing knowledge together to be able to make a difference. That's my interpretation of their work. Esri here in Saudi Arabia is going to advance. Our focus here is similarly to serve our users and serve you better. That goes deep to me. We made this move of going direct here because of the feedback that many of you gave us. We want to provide you world-class technical support and new opportunities for business partners to grow and serve each other here as a kind of ecosystem. You know, Esri is known for its technology, but also we have one of the top rankings of technical support and support for our user community. And we do this with not just hotline support, but also several hundred books that push the profession, different networks, the Esri community, and we're looking forward to advancing that with you here in the kingdom. A major part of our business actually is education and training, skills training for you. Each year we teach about 600,000 people in new courses, progressive learning programs, web classes, instructor classes, and much of this is free. We intend to Arabize this into Arabic languages and support the entire region with it in a more effective way. It's all about helping our users stay current and also advance their professional careers. A big personal interest of my own is education. And this is not just in colleges and higher ed programs. We do have quite a number of you from academic institutions here in colleges and universities. I would really like to get a GIS degree in a university here soon. Talk to me after this session if you're interested in that. Also, I'm interested in K through 12 or middle school education. Our software is running in 17,000 middle schools in the United States. That's partly because we worked with the equivalent of your Ministry of Education in the US and made all of our software available for free. And I want to do the same thing for kids here in the kingdom, helping students get more spatially literate, understand your work, but at a young age. Project-based learning exercises. So again, see me after this session if you're interested in that. Esri supports a huge ecosystem of partners. These are people that have embraced our technology and build value-added work, helping in services or helping new applications, and a number of them are right here in the kingdom. I want more of this, particularly with the startup vision that the Prince has in mind. Some of these are huge companies like IBM and Microsoft and Oracle and AWS, but many of them are little startup operations. And some of them fail, but many of them don't. And so I'm hopeful that we can encourage entrepreneurs here to do the same thing and join us. All right, I'm at the end of my talk here. I'll conclude it by simply saying the central problem, it seems to me, of our time is this lack of understanding and failure to communicate. And this is going to challenge our sustainability. Gets real personal real fast when we look at the world burning out in 50 or 100 years. The mapping and geographic approach and ultimately GIS are very practical means for us to address many of these challenges, to get it together as a human species. And from a technology perspective, we have moved so far in these 4 decades of GIS applications here in the kingdom. I mean, it's now possible to empower and involve everyone and make this kind of collaboration of working together really possible. I think in the next 5 years we're going to see dramatic expansion. Some of you would say this expansion of the market. I think of it as expansions of our field and our profession, actually. And speaking to GIS professionals, I'll repeat what I said before. You have a special responsibility to help people find this vision of common ground, to be able to provide the leadership, to provide collaboration, to advocate this as an activity, and work together, help understand things, and explain not only what is, but also create what's possible. I've written down a few final things I want to say to each of you, and so listen carefully. Basically you, what you do, how you do it really matters. No one else actually understands quite like you, or is equipped to provide the kind of solutions that you can. Now, depending upon how you think, I think of you as privileged. And at this particular point in human history of civilization, you're becoming called on to address some of these big challenges, to become part of this network, to provide the language and to provide the methods and to provide the enabling infrastructure that will help the world find solutions to these big challenges. And look, I think about this a lot. History's going to judge all of us, frankly, based on our success of being able to deal with this challenging time. So I want to thank you for being here. I want to thank you for all of the accomplishments that you make. I want to also thank you for working with me and my colleagues at Esri. When I was young, still in school, this man, Robert Kennedy, was still alive. He was the brother of our famous John Kennedy, who was a president. And he said, I was inspired by him as a student. He said, in your hands, not the president, not the leader, not the prince, is actually the future of the world. I'm not saying that leadership isn't important, but he said, in your hands is the future of the world and the fulfillment of the best qualities of your own spirit. I liked Robert Kennedy. He was a genuine person. You would have liked him too, I'm sure, if you had known him. But I'll leave this quote with you to finish off this morning and say, once again, thank you for being here, for putting up with my technical foibles here. And we're going to take a break now and come back in a couple of minutes.
شكرا جاك. ثانك يو. مع كلمة رئيس الهيئة العامة للمساحة والمعلومات الجيومكانية المهندس محمد آل مبروك، مساعد مدير عام المكتب التنفيذي لرئيس الهيئة، فليتفضل.
بسم الله الرحمن الرحيم. السيد جاك دانجرمون، أصحاب السعادة، السيدات والسادة، أيها الحضور الكريم، السلام عليكم ورحمة الله وبركاته. يطيب لي ويشرفني أن أقدم لكم هذه الكلمة يليها عرض مختصر عن الهيئة، وذلك نيابة عن سعادة الدكتور المهندس محمد بن يحيى آل صايل، رئيس الهيئة العامة للمساحة والمعلومات الجيومكانية. إنه من دواعي سروري أن أرحب بكم جميعاً في أعمال المؤتمر الأول لمستخدمي إزري، والذي يسعدنا احتضانه للمرة الأولى في مدينة الرياض. تأتي مشاركة الهيئة دعماً منها لأعمال هذا المؤتمر، وذلك انطلاقاً من مهامها التي أنيطت بها بموجب تنظيمها الصادر بقرار رقم 90 بتاريخ 5/2/1442، والذي أناط للهيئة العديد حقيقة من المهام التي سأستعرضها لاحقاً خلال هذا العرض القادم، والذي نسعى حقيقة من خلالها إلى الارتقاء بقطاع المساحة والمعلومات الجيومكانية في المملكة، وكذلك جهودها ودعمها المستمر في ريادة وتطوير نظم المعلومات الجغرافية كأحد الممكنات الأساسية في سعيها نحو الارتقاء بمستوى جميع الخدمات، حيث تسهم نظم المعلومات الجغرافية في تطوير الأعمال والخدمات ودعم منظومة اتخاذ القرار في مختلف القطاعات، مما يسهم في رفع كفاءة العمل الحكومي اعتماداً على جودة ودقة المعلومات الجيومكانية المتوفرة. لا أريد الإطالة عليكم، فأنتقل للعرض الخاص بالهيئة، والذي من خلاله سيتم التطرق إلى أثر وأهمية المعلومة الجيومكانية، ثم نظرة عن الهيئة العامة للمساحة وأنشطتها، ونختم هذا العرض بمشيئة الله مع التوجهات المستقبلية للهيئة. أبدأ بالجزء الأول من هذا العرض، والذي يبين أهمية وأثر المعلومة الجيومكانية. فإظهاراً لأهمية المعلومة الجيومكانية وكيف أنها داعمة حقيقة وممكنة للتنمية والاقتصاد والأمن، أستعرض ما نصت عليه رؤية المملكة، حيث ذكر ما نصه: وسنوسع نطاق الخدمات الإلكترونية المقدمة لتشمل خدمات أخرى مثل نظم المعلومات الجغرافية والخدمات الصحية والتعليمية. وهذا حقيقة تأكيد على مساهمات المعلومات الجيومكانية بالتمكين العديد من القطاعات، والذي يؤدي في نهاية المطاف إلى رفع كفاءة وتحسين الأداء. أستعرض من خلال هذه الشريحة بعضاً من الأمثلة على استخدام المعلومات الجيومكانية في المشاريع القائمة حالياً، فمنها مشروع The Line في مدينة نيوم، والذي تعتمد اعتماد كبير على المعلومة الجيومكانية في بناء البنية التحتية للمدينة، وكذلك التخطيط الحضري وكامل جوانب الحياة. أيضاً ما قامت به وزارة الاقتصاد والتخطيط من إنشاء بوابة جيومكانية تستخدم في تخطيط المشاريع المستقبلية، وكذلك ما قامت به وزارة الصحة من إنشاء لوحة بيانات جيومكانية تستخدم لتتبع حالات الإصابة بفيروس كورونا. كذلك البنك الدولي عندما قام بإنشاء بوابة جيومكانية تعرض أماكن أجهزة الصرافة والبنوك. أيضاً تعتبر المعلومة الجيومكانية داعمة لتحقيق أهداف التنمية 17 للأمم المتحدة، وذلك بوجود وتوفر بيانات جيومكانية ذات دقة وموثوقية عالية متكاملة مع البيانات الإحصائية أو الاقتصادية لتعالج قضايا مختلفة مثل القطاع الاقتصادي والبيئي وغيره، سيكون لها الأثر الكبير بحول الله في تحقيق هذه الأهداف. وهنا في الحقيقة يبرز دور الهيئة الجوهري على الصعيد المحلي من خلال تقديم البيانات والخدمات والمنتجات الجيومكانية لكافة الجهات داخل المملكة، منها على سبيل المثال الحصر وزارة التخطيط، البلديات، هيئة الإحصاء، والتي تساعد بحول الله هذه الجهات في تحقيق أهداف التنمية المناطة بهم. أنتقل للجزء الثاني من هذا العرض والخاص بالهيئة وأنشطتها. فحقيقة مرت الهيئة بالعديد من المراحل منذ لحظة تأسيسها حتى صدور قرار مجلس الوزراء رقم 90 في عام 1442. فتتمتع الهيئة بالشخصية الاعتبارية العامة والاستقلال المالي والإداري، وترتبط تنظيمياً بوزير الدفاع. ويتكون مجلس إدارتها من 22 عضو، 16 عضو ممثلين من جهات حكومية، كذلك ممثلين 2 من القطاع الخاص، وأيضاً ممثلين 2 من القطاع الحكومي الأكاديمي. طبعاً استعرض من خلال هذه الشريحة ما ورد في المادة الرابعة من تنظيم الهيئة، حيث تهدف الهيئة إلى تنظيم قطاع المساحة والمعلومات الجيومكانية والتصوير المتعلق بأعمال المساحة والمعلومات الجيومكانية في المملكة، والارتقاء به والإشراف عليه ومراقبته بما يحقق الجودة وتحسين الأداء، كذلك المحافظة على الجوانب الأمنية بالتنسيق مع الجهات المعنية، ولها القيام بكل ما يلزم في سبيل تحقيق أهدافها. ومن هذه المهام والمسؤوليات التي أنيطت للهيئة بموجب هذا التنظيم وضع المعايير والضوابط الأساسية والاسترشادية المتعلقة بالقطاع، كذلك اقتراح الأنظمة ذات العلاقة بالقطاع، أيضاً اعتماد وتطوير البنية التحتية الجيومكانية الوطنية والمرجع الجيوديسي الوطني والشبكات الجيوديسية الوطنية، كذلك المسح البحري الهيدروغرافي، وتوفير البيانات والمنتجات والخدمات والتطبيقات الإلكترونية، والخرائط الطبوغرافية والجوية وخرائط الملاحة البحرية. كذلك أنيط للهيئة إعداد الخطط الاستراتيجية، الترخيص لممارسة الأنشطة في القطاع والإشراف على تأهيل الممارسين، كذلك العمل على حماية المستخدمين أو المستفيدين من القطاع وتهيئة القطاع ليكون جاذباً للاستثمار وتحفيز نموه، العمل على الكفايات أو تطوير الكفايات الوطنية في القطاع، كذلك التنسيق والتعاون مع نظيراتها في الدول الأخرى من الهيئات والمنظمات الدولية، كذلك أيضاً تمثيل المملكة داخلياً وخارجياً فيما يتعلق باختصاصها، والإشراف على إصدار أطالس المملكة، والعمل على توفير المعلومات والدراسات الخاصة بالحدود، وأخيراً تقديم الاستشارات والخدمات المرتبطة بالقطاع. طبعاً من منطلق مسؤوليات الهيئة والتي منها التنسيق والتعاون مع نظيراتها في الدول الأخرى من الهيئات والمنظمات الدولية، تحرص الهيئة حقيقة دائماً من الاستفادة مما تقدمه هذه المنظمات الدولية من أعمال التي من شأنها الارتقاء بواقع الشأن المساحي أو القطاع الجيومكاني في المملكة. طبعاً تحرص الهيئة أيضاً على نقل هذه أفضل التجارب والممارسات المتبعة عالمياً في إدارة المعلومات الجيومكانية، فحقيقة تم الاستعانة بالإطار المتكامل للمعلومات الجيومكانية في العديد حقيقة من الأمور التي قامت عليها الهيئة مؤخراً، منها تطوير الاستراتيجية الجيومكانية الوطنية، أو أيضاً تطوير البنية التحتية الجيومكانية في المملكة. طبعاً الإطار المتكامل هو إطار معتمد من قبل الأمم المتحدة، ممثلاً في لجنة خبراء الأمم المتحدة بإدارة المعلومات الجيومكانية، يتكون من 9 مسارات الواضحة أمامكم. وقد شاركت الهيئة حقيقة ممثلة في الهيئة المملكة ممثلة في الهيئة في مراحل تطوير هذا الإطار، وأيضاً ترجمته إلى اللغة العربية، فيمكن الحصول على نسخة من هذه أو أجزاء هذا الإطار من خلال موقع أو زيارة موقع الهيئة الإلكتروني. طبعاً أنتقل هنا للحديث عن الأنشطة التنفيذية التي تقوم عليها الهيئة حالياً، وأود الإشارة أنه أعفيت الهيئة بموجب تنظيمها أو أعطيت 4 سنوات للقيام بالأعمال التنفيذية، ومنها المساحة الأرضية الجيوديسية، أيضاً المسح الجوي والفضائي، كذلك المساحة الطبوغرافية والمساحة البحرية، ومركز المعلومات الجيومكانية والذي من خلاله تعمل المنصة الجيومكانية الوطنية، وكذلك تعتبر الهيئة هي المرجعية الفنية لأعمال الحدود البرية والبحرية. هنا أود الحديث عن أحد أهم مكونات البنية التحتية للمعلومات الجيومكانية، وهي البنية التحتية الجيوديسية الوطنية. طبعاً نظراً لمتطلبات القطاعات الحكومية والخاصة، قامت الهيئة بالعمل حقيقة على تطوير البنية التحتية الجيوديسية من خلال إنشاء الشبكات الجيوديسية، وكذلك المرجع المكاني الوطني للمساهمة في رفع دقة الأعمال المساحية والإنشائية وغيرها. أما بخصوص المسح البحري الهيدروغرافي، فقد قامت الهيئة بجمع بيانات المسح البحري الهيدروغرافي في البحر الأحمر وخليج العقبة، حيث تم تغطية ما نسبته 100% من المياه السعودية وما نسبته 40% من مياه الخليج العربي. كذلك قامت الهيئة بإنشاء الشبكة الوطنية لمحطات الرصد والمد والجزر، وعددها 7 محطات على سواحل البحر الأحمر و5 محطات على سواحل الخليج العربي. أيضاً تمتلك الهيئة سفينة المسح البحري سلطان للقيام بأعمال المسح البحري في المياه العميقة، وكذلك زورقين صغيرين تستخدم في أعمال المسح البحري في المياه الضحلة. طبعاً هذه نماذج المشاريع التي نفذتها الهيئة، ومنها مشروع التغطية الوطنية ببيانات خرائط الأساس مقياسهم 1 ل25,000. طبعاً يعتبر هذا المشروع أول مشروع على مستوى المملكة من ناحية التغطية الجغرافية وأيضاً نوعية المخرجات. طبعاً يهدف هذا المشروع إلى بناء قواعد بيانات جيومكانية لخرائط الأساس مقياسهم 1 ل25,000 من مخرجات هذا المشروع: الصور الفضائية، خطوط الكنتور، المباني، نماذج الأسطح الرقمية والأودية وغيرها. كذلك مشروع إنتاج صور تاريخية مصححة المملكة، أيضاً مشروع جمع وحصر أسماء أو أماكن الأسماء الجغرافية، وكذلك مشروع الغطاء الأرضي واستخدامات الأراضي لكامل مساحة المملكة. طبعاً من ضمن الأعمال التطويرية حقيقة التي قامت عليها الهيئة والتي من شأنها الارتقاء بقطاع المساحة والمعلومات الجيومكانية هو إنشاء ومن ثم تطوير المنصة الجيومكانية الوطنية لهدف الحد حقيقة من الازدواجية في الأعمال، وكذلك رفع كفاءة الإنفاق بين الجهات الحكومية من خلال نشر وتبادل البيانات الجيومكانية التي تنتجها هذه الجهات. طبعاً آلية عمل هذه المنصة هي كالتالي: يتم تزويد الهيئة بما لدى الجهات من بيانات، تقوم الهيئة بأعمال ضمان تكامل هذه البيانات فيما بينها من خلال إسنادها إلى المرجع المكاني الوطني، ومن ثم نشرها وتبادل البيانات مع المستفيدين من خلال هذه المنصة. كما أيضاً تعمل الهيئة بتقديم الدعم للجهات المختلفة بإنشاء تطبيقاتها الخاصة على المنصة الجيومكانية الوطنية، وهذه المنصة مستضافة كاملاً لدى الهيئة السعودية للبيانات والذكاء الاصطناعي. أنتقل للجزء الأخير من هذا العرض والخاص بالتوجهات المستقبلية للهيئة. طبعاً هذه الدراسة هي مدخل لأحد المواضيع التي تعمل عليها الهيئة حالياً، وهو إنشاء الذراع التنفيذي. طبعاً هذه الدراسة قامت بها الهيئة بالتعاون مع البنك الدولي عن مدى تأثير المعلومات الجيومكانية في اقتصاد المملكة، والذي من المتوقع نموه من 22 مليار إلى 40 مليار. كذلك قامت الهيئة بتزويد البنك الدولي بعدد من حالات الاستخدام المحلية، تم إضافتها مع عدد من حالات الاستخدام العالمية لتنفيذ هذه الدراسة. طبعاً تم اختيار 7 قطاعات الواضحة أمامكم مقرونة بحالات الاستخدام، والعمود الأخير يوضح الأثر الاقتصادي السنوي لكل قطاع. طبعاً هدفنا الاستراتيجي من إقامة الذراع التنفيذي هو أن يكون هذا الذراع مرن أو ذراع تنفيذي مرن يحقق متطلبات القطاع الجيومكاني في المملكة، أيضاً يحقق الاستثمار في الخدمات ويقوم على الشراكات بين القطاع الحكومي والخاص، وأن يوفر هذا الذراع البيانات الوطنية المطلوبة، ويضمن تحديث المستمر للبيانات الجيومكانية، وأيضاً يسهم هذا الذراع إلى تحقيق الأمن الوطني للمعلومات الجيومكانية من خلال توطين الوظائف وشغلها بالكفاءات الوطنية، وأيضاً أن يسهم هذا الذراع في تحقيق كفاءة الإنفاق وزيادة الموثوقية. طبعاً أختم بهذه الشريحة والتي تتعلق ببناء القدرات. فمن خلال دراسة واقع الشأن المساحي التي قامت بها الهيئة، وجدت أن هناك أكثر من 13,000 وظيفة في القطاع الخاص يشغل السعوديين منها ما نسبته 8% فقط. أيضاً من خلال ورش العمل والمقابلات التي تمت وأجريت مع شريحة كبيرة من القطاع الخاص والعام، اتفقوا على عدم توافق حاجة السوق من اختصاصات أو مهارات المتخرجين مع هذه المتطلبات. أيضاً هناك نسبة ضئيلة جداً لممارسي التخصص في المملكة في القطاع التعليم الجيومكاني، والموجود حالياً هو عدد ما يقارب 90 ممارس. أيضاً ضعف مستوى الممارسات الوظيفية والتقدم الوظيفي والرواتب، حيث لا يوجد تصنيف للمنتمين لهذا القطاع كالتصنيف الموجود لهيئة المهندسين، يساعد في تحديد الحد الأدنى للرواتب أو التي من شأنها حقيقة رفع زيادة الإقبال على هذه التخصصات. فكخطوة أو كخطوات حل لهذه المشكلة، تطمح الهيئة حقيقة إلى تطوير البرامج والمناهج التعليمية ضمن المدارس والجامعات المتخصصة ودعم البحوث الجيومكانية. كذلك تنظيم القطاع الجيومكاني الاحترافي من خلال التعاون مع صندوق تنمية الموارد البشرية والجهات ذات العلاقة بهدف توحيد مسميات الوظيفية للقطاع الجيومكاني، وكذلك مسارات التقدم الوظيفي، وأن يكون هناك سلم رواتب لتعزيز جاذبية القطاع وجذب المواهب. كذلك تأسيس أكاديمية متخصصة بالقطاع الجيومكاني لتطوير الكفاءات المحلية، وكذلك ذلك عن طريق تقديم برامج تدريبية ذات علاقة بالقطاع. كذلك إنشاء بوابة يتم من خلالها الإعلان عن الوظائف الشاغلة في القطاع، وإنشاء منصة موحدة بالتعاون مع الجهات ذات العلاقة لتوفير معلومات عن المواهب الجيومكانية، وكذلك توفير معلومات عن البرامج التدريبية المتاحة. بذلك أصل إلى نهاية عرضي لهذا اليوم، شاكراً ومقدراً لكم استماعكم.
شكراً مهندس محمد، يعطيك العافية. حقيقة بالنيابة عن جاك أصالة وعني، حريصين بعد الشكر على العلاقة الاستراتيجية مع الهيئة العامة للمساحة وتطويرها قدما بدعم المبادرات يلي عرضت. فحب نذكر هذا الشيء قبل ما نروح على الاستراحة لثلث ساعة إن شاء الله، ونرجع الساعة 11. We will break for 20 minutes and back by 11. Thank you.
بسم الله الرحمن الرحيم. كويس؟ تست.
السيدات والسادة الكرام، نأمل منكم التفضل بالجلوس على مقاعدكم. سنبدأ بعد لحظات من الآن. Ladies and gentlemen, please take your seats. We're starting shortly. السيدات والسادة الكرام، نأمل منكم سرعة التفضل بالجلوس على مقاعدكم. سنبدأ الآن. Ladies and gentlemen, please take your seats. We're starting now.
بسم الله الرحمن الرحيم. Assalamu alaikum. Hello, ghala fikum. Good morning, everyone, and welcome to the first Esri Saudi Arabia User Conference. I'm honored to meet you here today and to be part of this amazing event, which is held in our beloved country. Let me introduce myself first. I am Lubna Kutbi, a UI UX designer and a graphic designer as well. Did you see this design here? I worked with the designing team to come up with the theme of the user conference, from this screen to the badges you're wearing. I hope you all like it. It's like a dream coming true for me. Thank you so much. Thank you. I joined Esri Saudi Arabia last year, and it was a brand new experience and field for me, since I learned a lot about GIS and things I never thought about. And that made me wondering, who's the person who built such an amazing company with this big GIS system? Who is he? Yes, he's Jack. Did you all saw his presentation? It was so awesome. Since he talked about how Esri helped all of us achieve our mission and how GIS technology used for mapping a common ground, and how GIS system of Esri is going to help the vision of 2030 of Saudi Arabia, from serving our users across the kingdom to supporting spatial literacy, conservation, and education. Now we will move with the Esri team to learn more about ArcGIS and how we positioned GIS as a comprehensive integrated system and how to use it to fulfill various use cases. Let's welcome Hussam Sayed. The floor is yours.
Thank you. All right, thank you, Lobna. It's really very exciting to see the young Saudi generation really getting into GIS and doing wonder things. This is really very refreshing. So it's an honor to be back in Riyadh. I see a lot of familiar faces, some of my nice friends, old friends, still friends. So some of you don't know that, but I lived here about 6 years ago, so this is really like going back home. It's my second home. I have to say there's a lot of changes in the kingdom. I mean, even this place that we are in here, when I was leaving about 6 years ago, it probably was about under construction or about to be finished. So a lot of changes going on in the kingdom, a lot of good stuff happening. So really exciting to be back in Riyadh. So you saw Jack talked about the vision and the ArcGIS platform and what we're doing now. We want to focus a little bit here about our capabilities. And we have the whole Esri team to show you really the technology. We like to show technology in actions. And a lot of you are familiar with our plenary, and we like to show technology, not just talk about it. So a lot of exciting demos. So stay here. We have this part, and then a break and another part. So really a lot of good stuff we're going to talk about. Now, we listened to Jack. We talked about the ArcGIS platform. But let's reiterate, what is the ArcGIS platform is really? It is one comprehensive system. It has different components, but it's one big system that has many, many capabilities. It serves multiple kind of group of users, or what we call communities. There is the people who are interested in mapping and location. That's the traditional GIS. There is the analytics part, a lot of tools for doing spatial analytics. There is the imagery, have we seen, and we're going to see it more in next demos. The imagery capabilities has really advanced in the ArcGIS platform. And it's also for developers to develop really custom apps as you want. There's a lot of you are really doing sophisticated stuff that you need to go beyond the out-of-the-box tools. All of this is available really as in two offerings. It's a software as a service on the cloud, which we call ArcGIS Online, and it's also available on your own premise or in your service, which is the ArcGIS Enterprise. This whole system is really an integrated system. It acts as one unit. It can be experienced in multiple ways. People can use the GIS system on a desktop. You can use it on the web browsers, or you can use it on your mobile devices. And all of this can be integrated behind on the back end, on the server side. As I said, this server side could be on the cloud, your private cloud, or it could be on the public cloud like Azure or Amazon. But all this is easily integrated with your IT existing infrastructure. As we like to call this, the geospatial infrastructure. So really you can easily make this available to the entire organization. So there's different ways you can think about all these tools about. So one of the ways is that traditionally you use the system to record your data, which is what we call the system of records. A lot of you works with cadastral data, pipeline data, like my friends in Aramco here, parcels data. Traditionally you edit this, you keep it. That's what we call the system of records. But then you make this available to the entire community, and then not just make it available for access, but you make them do analysis on that and make the analysis available. So this is what we call the system of insight. You really provide more insights out of this data using the analytics and make everybody find out more information from these analyses. Some of you are familiar with this already, but some of you didn't use it yet, but there's these new ways of reaching out to your users, not just your familiar professional users, but even to the public. There's a lot of tools to do that, and that's what we like to call the system of engagement. This is how we engage with our user. It's not just reaching or sharing, it's engaging. It's a two-way communication with the users. So these are the three main categories of using using our ArcGIS platform. One of the capabilities that a lot of our users not aware about is that, or not using it much, is really that our ArcGIS platform is a content sharing platform. Not just within your organization, but you can use it to the public. A lot of you have data, secure data. You can share it within your organization, but if you have something that is not very secure or you want to share it with the public, it's much easier and cheaper to use the Esri cloud and share that with everybody, and the system will allow you to do that. The platform is really an open platform, and it was designed on the open architecture principles. You can easily integrate with the other system using the open standards. It was built using this FAIR principles, so it's really, if you're not familiar with that, this is the open source or the open architecture ways of designing systems or standards. It stands for findable, accessible, interoperable, and reusable. So if you think about the ArcGIS platform with all its components, it is really supporting the open standards and easily can be integrated with other systems. All these components are really advancing rapidly. As you've seen through the years, we have been adapting and working with a lot of the IT new technologies like IoT, big data, machine learning, security, the cloud. All this is now part of GIS. So GIS is really at the heart of the IT, all these new technology happening now. And we're keeping advancing. Have you've seen what Jack talked about, all this exciting data that is available on the ArcGIS platform? And again, this is another thing that is not very widely used, but think of it, there's a wealth, there's a fortune of geospatial information, data available for all of you, free of use, is if you are the ArcGIS platform user, you can search, find it, and use it within any of your component, desktop, developer, or web. This is what we call the living atlas of the world. There's plenty of data there that you can use. There's satellite imagery, Landsat since it started. There's the even one of the exciting ones, the OpenStreetMap 3D layer. They have 3D layer of all the main buildings around the world. All this stuff is really available for you to use. You can use it within your ArcGIS Pro or any of your other components. It's available in a very easy way to use. And Esri curate this data and use it. We bring it from commercial sources. We bring it from authoritative sources. Some of our users around the world, they share some of their data. It's much easier for them to make Esri make it available. They don't have to have massive infrastructure. Esri will take this data, happily curated, make it available for everybody to use. So this is a lot of stuff you can really include in your analysis even, and do sophisticated analysis in that. It just works with any piece of the platform. I really encourage you to look at this. Also, our ArcGIS platform is really a complete mapping and cartographic system. We've seen Gasky and the Morgan talking about producing the maps. They're one of our main users here in the kingdom, and they're using our tools to create cartographic, beautiful, professional cartographic topo map and defense map and others. Even the maritime people who are looking at the bathymetry, they can use the tools to create that. So we have these rich capabilities to create cartography and create beautiful maps. And this all can be available either on the web, on the mobile, or even as a developer if you want to include this in custom apps. And speaking about the professional, cartography, as you know that our desktop ArcGIS Pro is our main tool, and you can use that to create really rich and professional-looking cartography. We have a demo coming talking about what's new in ArcGIS Pro, and you can see this in action. But there's a lot of new things like dynamic map, dynamic symbols, 3D symbols, and a lot of enhancement in performance. You can see here in this list to the right all these new tools. We will probably need the whole day to talk about them. One of these also really advancing capabilities that's, especially in the last 2 or 3 years, it advanced a lot, the web mapping and visualization. Now, within your browser, whether in your premise or on the cloud, you can actually do some really rich and good-looking cartography using the web map capabilities. You can see here in the middle this web map here. We can see that we are dynamically on the browser, filtering massive amount of data and changing the thematic map based on the filter I do. This is all done on the browser side. It's in the web. It's not a desktop application. And this has happened because of all the advancement and increase in performance that we did recently. A lot of new tools. This is some of the things that excite us a lot, really. So all these rich web map, when you create them, you can share them as is, but you can also share them in a different way. You can share them actually as apps. You can let people browse them, compare data to each other, look at the profile, do different things. So using the instant apps, there's a bunch of available templates on the platform that you can use to make your data available to the user so they can access it, not just by looking at it, but using it in different ways. I can talk about this on and on, but instead of talking that, I'd like to welcome my friend Ahmed Al-Husseini here, who is going to really show us how this instant app works. And before we start, I'd like to give him a challenge. Okay. So I've been saying that instant app is really easy to do. Can you create an instant app in less than 5 minutes?
Of course, yeah, absolutely.
All right, let's see.
Hossein has challenged me to create an application using an existing web map that is shareable with the public in under 5 minutes. As part of a recent project I was working on to study the availability of housing in Toronto, I created a web map that shows the number of housing units available and the average cost of real estate for each neighborhood. I also have the data for the median income for each neighborhood. Combining those, I will create a web application that allows users to view the availability of housing, cost of real estate, and be able to compare that to the median income for each neighborhood in Toronto. This will allow them to glean some insight into the relative affordability of housing in Toronto and make an informed decision about where to move. This is what the application would look like. It has a legend explaining the colors and sizes of the housing data you see on the map, and you can easily swipe between the median income and the cost of real estate to get a better understanding of the affordability of housing for each neighborhood. So how was I able to achieve this in under 5 minutes? Well, starting here with my web map, it already has my existing layers. From there, creating an instant app allows me to quickly convert this web map into a web mapping application shareable with my users. The Instant App Gallery has a wide range of available options based on the common use cases and scenarios that we have seen our clients develop. The names of the templates are a great guide of what to expect of the application, but also a description is provided for each of the application templates. Previewing the application with your own web map gives you a sense of what the application would look like before you commit to any of the templates. I'll start here with the media map template. From there, users can quickly set up the application, simply toggling on and off the mapping elements they would like in their application. I added a layer list to allow users to toggle between layers. And if that is not enough, switching to full setup provides a larger host of tools for interactivity. I've done that to enable the swiping capability between the median income layer and the cost of real estate layer. These applications can also be contextualized, branded, and themed according to your own organization's needs, controlling the user interface with just simple switches. All I need to do is hit publish, and just like that, I have a web mapping application that is shareable directly through linking, via social media, or even through embedding it into my own website. And the best part is that this application is already optimized to work in desktop and mobile devices in portrait and landscape modes. In under 5 minutes, 3 minutes even, I was able to convert my web map into a web mapping application that I can share with my users with complex capabilities that would have previously taken much longer to custom develop. That is all thanks to ArcGIS Instant Apps empowering the functionality. So, Hosam, challenge accepted and challenge completed. Back to you. Thank you.
Great, thanks a lot. So you really succeeded. Thanks.
Thank you very much.
So Ahmed showed us really this capability that how to create an app in really very short time, probably 3 minutes he did that. One thing that I want to highlight here, this is not just available on ArcGIS Online, it's also available on ArcGIS Enterprise. So you can do this from within your own network. You don't have to share this or do this on the public cloud. The same thing available on-premise and online, which is great. All right. Next, I'd like to talk about some of the exciting work we've been working with Microsoft for a long time. A lot of you know we already have a strategic relationship with Microsoft, and we've been working together on many things. We have what we call mapping for the Microsoft 365. That's a product that allows all the Microsoft users to have or enjoy and use all the GIS capabilities from within the traditional Microsoft products, the Office products like Excel, like the Power BI, even recently Teams. A lot of you are using Teams now for all meetings. And even you can automate, include them in the automation like Power Automate and things like that. This is really provide a lot of GIS functionalities to the regular users. And you can extend the use of GIS to the non-GIS users, to the people who are just using Excel or Word. So you can extend the reach of your capabilities within the organization. Another capability that a lot of you are using for a long time, and it's really become so popular now, is really the ability to do storytelling, or what we call story maps. People are using this to brief their superiors about their work, brief the public about any events going on. So these story maps that allow you to start with a web map, and there's a lot of other available templates that allow you to tell a story or a geographic story in a certain way. We've been working on this for years, and this is becoming one of the most popular, pieces of the platform. And you've seen we've made a lot of enhancement in it. You can see in the middle here these 3D capabilities. Now you can have a 3D map tour from within the story map. All you have to do is start with your scene, just select the template and add some, configuration, and you can tell the story in 3D. And there's many more features you can see on the right here. Now we have a different version of that, what we call the personal storytelling. What we talked about is the professional one that you've been familiar with for a long time. Now anybody can have this and use it to report or tell everybody about their travels, or about anything exciting about their ancestors, where they lived, where their father or grandfather lived, and what is the story about the old village they came from. And this is now available for anybody to use. And it's actually, when you launch this and it's still available, everybody can use it for 1 year for free. You don't need to buy anything. So this is another exciting capability. And if you've seen, and when Jack talked about the dashboards, the Johns Hopkins, he talked about the Johns Hopkins dashboard. I mean, really, Johns Hopkins really changed, brought this dashboard, our dashboard to a whole different level. And the dashboard is really one of the most popular tools, and been using it. But Johns Hopkins dashboard, when they were reporting on the pandemic, it brought it to a whole different level. It actually was for a few months, it was the official, or probably the only source available for the entire world to report on the spread of the pandemic. So really, the dashboard is a great tool to show your work. It is not just about, as you know that, it's not just about sharing data, but it's all about the analytics as well. So the ArcGIS platform is a complete and comprehensive spatial analytics system. So there's so many capabilities available across the platform. Graph analytics, AI, machine learning, we're going to see this in a few minutes. And you've seen that we worked with a lot of the tools. A lot of you you've been working with the traditional GIS analytics. A lot of you work with us also in the AI and machine learning about that. You can do modeling. You can actually do scripting to model your spatial analytics. You can use the model builder. Or you can use it on the big data as well. If you have massive amount of data, you can use spatial analytics. And we're going to show this in a minute. So speaking of big data and analytics, as I've seen, if you have massive amount of data, you can use the machine learning to work on that. But also, there's a lot of tools that Esri make them available as free. And a part of the platform, you can use them as is. They are actually out of the box. There are a number of algorithms you can use to do feature extraction, to do image processing, a lot of tools that use AI and machine learning, and we train them and make them available for you. You can use them as is, or you can train them and actually to your data and do further work. And we're going to see this in a while. So this is what we like to call the geo-AI capabilities of the platform. One of the tools that also is a lot of people don't know about it is what we call ArcGIS Insight. So ArcGIS Insight, you can think of it as a dashboard for doing exciting spatial analytics. So instead of sharing the data or a report, a fixed report about the output of your analysis, you can actually share a dashboard, an interactive dashboard that shows the spatial analytics of your data, so allow people to explore your data and do their own queries as well. So there's drag and drop tools that you can do. You can do network analysis in it. You can explore the different data. You can do charts, tables. This is one of the things that you can use. It's also available on-premise or on the web. So ArcGIS Insight is really a powerful tool to communicate your analysis. A new capabilities that we recently did is what we call the graph analytics. So some of you might not be familiar with the concept of graph analytics. The graph analytics is really analyzing a lot of, usually it's for analyzing a lot of non-spatial data. So think of social networks that has a lot of data, how you can find out who's connected to who and what's the connection between them. This is the traditional graph analytics. We brought this graph analytics into the ArcGIS platform. You can look at this the relationship between the entities, which mostly non-spatial, but then link them to the geography and do further analysis on them. Without talking too much about it, I'd like to welcome my good friend Yahya Hassan, who's going to show us this new product called ArcGIS Knowledge, which allow you to look at these graphs and how to analyze them.
Thanks, Hossam. Hurricane Ida made a landfall in the US in late August 2021 as a Category 4 storm. The forecast of extreme rain and flooding in Louisiana led many people to evacuate. But for those who remained, the storm devastated the power grid as they're there. One of the nonprofit organizations actually that helps in responding to this event was actually Direct Relief. Direct Relief works with local partners all over the world to distribute medicines and pharmaceutical supplies to people in times of emergency. These are some of the health clinics and hospitals in Great Louisiana region who requested assistance after Hurricane Ida. Direct Relief committed over $1 million for relief efforts. These are some of the health clinics and hospitals in the Greater Louisiana region who requested assistance after Hurricane Ida. The new knowledge graph capability in ArcGIS will let us explore the aid shipments they sent in a whole new way. The aid shipments are comprised of individual materials like these hypodermic needles. There are also packaged into shipments like this one, and sent to local health clinics like Baptist Community Health Services. The knowledge graphs allows us to define relationships in the data, and this diagram illustrates how the supplies are connected to the shipments that are connected to the organizations. Direct Relief sends hundreds of shipments after Hurricane Ida, and the knowledge graph makes it easy to trace these materials all over the way through the data. So how did we create this? Well, it starts by transforming the data like the inventory of medical supplies into entities and relationships. ArcGIS Knowledge is a new enterprise capability that enables us, through the knowledge investigation view in ArcGIS Pro, to work with data in knowledge graph. On the left, we have the type of entities and the relationships that connect them. Let's focus on one medicine, insulin, and we'll trace it through the graph to discover where it was sent. This is a linked chart. It displays the data as if we were to draw it on a whiteboard, and it helps us to interact with the graph data. Let's expand out from these insulin products to see what we went where. So, which shipments contained insulin? And we can keep going. Who received these shipments? This shows us to whom the supplies were sent. But what's really exciting about Knowledge Graph inside of ArcGIS is that we can focus on the geographic perspective and see exactly where it went. But the direct relief aid shipments are not quite that simple, because some of these red organizations we see redistribute the supplies they receive to other clinics that's not related to them. So let's expand out and see those places too. The knowledge graph on the right make it easy and fast to work with connected data. In this example, we see the direct relief aid distribution network for insulin, and we're able to understand what direct relief sent and who they sent it to, and where it went even indirectly. Let's say that direct relief wants to add a new partner in Louisiana to increase their reach and help more people. Who else could this partner with? Here are all of the possible partners. We can actually have it as a data set on the left side, and I can show it here on this map with the communities that they each serve. For the greater Louisiana, we can apply now graph analytics to analyze these relationships to determine which of these organizations would be the best new partner using the betweeniness algorithm on the bottom right side. These are the 3 most connected organizations. They serve the most communities who have the least access to healthcare. Along with graph analysis, geography is key, especially during a disaster response. Direct Relief will also want to consider where these organizations are located, because this impacts their capacity to dispense aids or care for their patients, and which areas are frequently evacuated or experience lengthy power outages. Based on this consideration, when Community Health Center is a strong candidate for partnership to help Direct Relief distribute humanitarian aid in Louisiana. You know, this is just one example of using this technology. It can also be applied to a lot different fields, like if you are managing a network of assets, or investigating crimes, or examining spending patterns. This is a hybrid approach to understanding our data in the context of space, time, and relationships. And it can help us make more informed data decisions making. Thank you, and back to you, Hussam.
Thank you. Thank you, Yahya. That was great. So this is another new capabilities in the ArcGIS platform. This is exciting, really. Through my career in GIS, every year we have something new, exciting. We have to keep learning. This is great. I want to shift now to talk about the imagery. And this is another one of the things that in the last 2 to 3 years really advanced a lot in the ArcGIS platform. So really, we can really say that ArcGIS is a really comprehensive imagery system now. It has many capabilities that range from imagery data management, to mapping and visualization using the imagery, to analysis and advanced analytics on imagery, and many visualization tools. So the imagery analytics and visualization really advanced. There's so many things that you can use in the ArcGIS platform now. We have capabilities for the digital photogrammetry. There is the raster analytics, which really work on massive amount of data on the cloud. There's the point cloud visualization now. There is the video analytics capabilities. And also there is the GeoAI and feature extraction using artificial intelligence and machine learning. Again, I can talk on and on about this, but it's better to show this. So please welcome Ali Al-Fanekh, who's going to show us how Esri, Saudi Arabia adapted actually out of the box algorithms that Esri make them available. They adapted them to the Saudi geography, so make them much working in a more refined way with the geography here in Saudi. So Ali, please.
Thank you, Hussam. Inspired by the Kingdom's Vision 2030 and the growing interest in artificial intelligence and its applications in a variety of fields, Saudi Arabia is going through different cities or development projects that need frequent data updates. In Esri, Saudi Arabia, we recognize the need to create local GUI modules that can produce better output based on the kingdom's topography and urban distribution. Our local team in Saudi Arabia trains specific models for building footprint extraction that fits effectively with the diversity of geographic locations in the kingdom and take into consideration the variation of the urban structure between different cities such as Riyadh and Mecca, Medina, Qasim, and other cities across the kingdom. A typical GUI workflow starts with preparing sample data. This sample data is used to train a model to produce the expected output. Once we are satisfied with the output accuracy of the module, the inference phase can be started to apply the model to the whole area of interest. We will use ArcGIS Pro in this workflow, but the same workflow can be used in ArcGIS Enterprise and ArcGIS Online. I'll begin with the data preparation step. I'll create a sample data using the Imagery tab in ArcGIS Pro and start digitizing the footprint of the sample data and classify each feature with the user-defined name, building in our case. I'll continue digitizing features as much as we can. The more training data we have, the better the model accuracy will be. We need to create relevant data coverage that represents the variation in building footprints. So after the sample data creation is completed, I'll export the training data using the export training data for deep learning tool with the required parameters. These parameters need to be configured carefully to assure an accurate model. So in the second step, the process of training the model is iterative. We might need to change the parameters many times and even add more sample data until we are satisfied with the model, with the output accuracy. The third and last step in this workflow is the inference stage. I'll use the detect objects using deep learning tool with the required parameters. The inference phase is the most resource extensive stage. Once the inference stage is finished, we will have now extracted vector GIS data that can be GUI enriched with other attributes and used for further spatial analysis and editing workflow, as you can see now. We've availed these modules through our GUI portal. These modules are ready to use for all our users in the kingdom at no additional cost. The current modules available in the portal are for building footprint extraction, blocks and street extraction, building point and classifications, and increase image resolution as well. And also more modules will be added soon. Our R&D team also implemented a promising module for real-time video analytics for plate recognition and detecting moving objects directly from live stream cameras. Esri is availing many modules that are available for our end user to use directly. Please benefit from these modules from our local team, and also they are ready to train you and lead you to tailor these modules to your needs. Thank you for listening, and now back to you, Hussam.
All right. Thanks, Ali. This is great. So you too can use the same process that Ali showed us. You can start with one of the algorithms that Esri make them available, and you can refine them and train them on your own data. Or if your geography or your data is very similar to what Ali showed us here, which is, I believe this is the Riyadh, you can probably use his algorithm out of the box and probably will get very good results. But that's the beauty about the AI. It's now available for the non-data scientists to use out of the box to a great deal or a great percentage of success. But you can even further refine it if you want. Now, moving a little bit about, we're talking about imagery, but imagery also, it's just not just about analysis, but we can also use it for data production. We've seen the impressive video that Jack will show us in the morning about the city of Stuttgart and how the realistic 3D mesh. This is all can be done with the new technology we have, which is called Sure for ArcGIS. So Sure for ArcGIS, to recap what Jack said, it's really by, you can fly or get stereo or overlapping imagery and feed them to the Sure for ArcGIS, and it will automatically create this 3D mesh, which looks realistic, and you can use that even to overimpose or superimpose on your 3D extruded features and to have a very hyper-realistic 3D looking data. So this is really revolutionary. And it's available for you to use. You can either buy these aerial imagery, or if you have your own planes, you can do that. On a smaller scale, if you have drone, which is, I think, drone technology is becoming very advanced and much cheaper than it used to be. So a lot of our users acquired their own drones. So you can fly your own drones, get this aerial imagery, and use the tools to create also 3D mesh or hyper-realistic 3D data. We have actually two software to do that. We have the Drone to Map, which is you can use, and you are probably a lot of you already using to map to plan for the flight and get the data and process them and create 3D meshes, them, or even sometimes contour data. But also there's another tool that is available as a software as a service. It's available on the web. It's called SideScan, which also take this imagery and create point clouds out of them. So these data are much easier to use now, and you can see the images in the middle here, that the output of this data. It's really much easier to use than before. So we can say really the ArcGIS is a 3D comprehensive system. It has multiple things for storing this 3D data, the system of records of 3D data, and make them available to a lot of your users in web or desktop or even in custom apps. So the city of Singapore is one of the pioneers around the world. They created a whole digital twin version of Singapore using the ArcGIS platform, and they hosted that and make them available to all their users. Not just above the ground, but also under the ground. You can see here on the right, and all this can be available on the web as well. So all this 3D digital twin. A lot of people talk about the word digital twin. So for us as GIS professional, this could be 2D version, a 3D version, but it's nothing more than, well, it's probably more, but it's primarily the system of records of recording this data and make them available. But the GIS can do a lot more than just having a twin. You can do analysis, you can share this information, you can interact with the user. There's a lot of things you can do with your digital twin. So there's many 3D capabilities we looked at, the visualization, the editing, the supporting different formats like the BIM and others. All these can be available on the desktop professional tools. We're going to see this in a minute, or even on the web or on the mobile as well. One of the new capabilities that recently is advancing and we started working is actually released last year in the user conference around July, a new capability called that actually work on the 3D immersive experience. We all watch the goggles, you know, these virtual reality goggles, and you can put them there. They are so advanced now, and you can look around and see where you are. Probably your kids or your young brothers worked in this and played games. Now they might be able to play games with actual GIS data. So we have this new tool, or a new SDK actually. It's not a tool, it's for developers. We call it the ArcGIS Maps SDK for the gaming engines. The gaming engines, if you're not familiar with, these are where the people who develop games for Xbox or whatever, develop games, they use this SDK to develop games. So a lot of the time they want to use these realistic GIS data and put them into the games. So now this SDK can allow you to bring your geospatial data, embed them in these games, and the developer can actually create a whole new experience of looking at the data. I think Jack also showed us a little bit how to do that in the morning, and we're going to show more. Again, I can talk more and more and more, but I don't like to talk much. We actually want to show the technology. To do that, again, I'll welcome Ahmed again to show us how the ArcGIS Maps for SDK works. Ahmed,
Thank
please.
you, Hossam. The ArcGIS Maps SDK enables developers to be able to create unique gaming experiences, relying on real-world data and bringing the power of ArcGIS to gaming engines to be utilized in VR headsets. Today, I will talk to you about 4 such examples. Over here, we can see the first example of navigating through a city, exploring neighborhoods and streets collected. All of this data was captured from reality by drones, creating a 3D digital twin of the city, sitting in the ArcGIS Online organization. We can see such incredible detail in it, including storefronts, street furniture, and even decoration details. The second example focuses on flight data. It shows us how we can simulate flight paths through terrain data coming from ArcGIS Portal, or even 3D data of a city, all from your traditional geospatial infrastructure. We can see how a plane would fly over the city and explore what that would look like. I must warn you though, this one can get you a little dizzy in VR. The gaming engine also offers us the ability to combine this geospatial 3D data with full control over the environment variables. We can control the atmospheric variables, such as the weather. Seeing here it is a little cloudy. And we can also control the time of day. All of these experiences are enabled by the ArcGIS Maps SDK for both the Unity and Unreal gaming engines. In this third example, we are in the Unreal editor exploring the use case of identifying the effect of the 2020 Australian wildfires on the environment. We can start by inserting the feature data from ArcGIS Online for the wildfires and visualizing them in the editor to be immediately visible. After inserting the data, you can see the resulting smoke and how it is affecting the atmosphere. The direction of the wind shows how the smoke would spread and where it would go, helping meteorologists predict weather patterns and aid missions to be more proactive in mitigating health risks. Switching to a closer view gives us a much better understanding of the reality of the situation, bringing us closer to the data than ever before, and allowing humanitarian and rescue missions to plan and perform so much more efficiently and successfully. The level of detail and realism are so incredibly high, and all without any cost to performance, thanks to the optimizations done by the Maps SDK working together with the gaming engine. In this final example, we showcase the interactivity possible when we combine virtual reality with the ArcGIS Maps SDK. The geospatial data coming from the existing infrastructure, whether of a mountainous terrain or a 3D city, enable users to not only view the data, but also experience it and interact with it, placing markers and game engine objects directly in the virtual reality, exploring different scenarios, and enabling better decision making. Thank you, Hossam. Back to you.
All right. Thank you, Ahmed. This is a whole new level of excitement, really. It's about gaming, so we can play games using our GIS data. This is great. I think a lot of, as Jack was saying in the morning, there's some of the pioneers of this technology is here actually in Saudi Arabia, and we work with them as early adopters. So this is really, you should feel proud about that. This is exciting. All right, moving on. So we talked about a lot of things. We talked about 3D, a lot of things, different kind of data. So you can probably know that already, but ArcGIS is really a comprehensive geospatial data management system. You've seen that we work with so many different kind of data. We have capabilities to edit these data, to share them, to group them, to index them, and you QA, QC, edit them, and make them available for multiple users through multiple experiences, whether on the web, on the desktop, or even on by scripting or for developers. So these different kind of data can all coexist and work together within the ArcGIS platform. You know, now a lot of you work with BIM data now. This is all available, and we're going to see another demo after the break, how to integrate CAD and BIM data with GIS. We see 3D. We're going to see in a few seconds here the velocity and what is the IoT and real-time data. So many different kind of data that can, the GIS data can actually, or the ArcGIS platform can work and make them available. One of the exciting things that not a lot of people use, especially or know about it, is the voxel data. This is a special format for scientists and people who do like exploration, like the oil and gas, how to look at the volume of the data on Earth or on the ocean and collect data in 3D and how to visualize that and interact with this. So a lot of very advanced ways of looking at different kind of formats. As I said, this is all available within the platform. There's different editing capabilities. We're keeping enhancing these capabilities. There's 3D editing tools now within the platform. You can work on it on the web or on the desktop. A lot of things in the improvement in the database. This by itself could take a week to discuss in details. One of the things that also is very popular is the field operations. You know, the Survey 123 is one of the most popular pieces of the platform. A lot of people are very quickly, easily create surveys and actually they save them a lot of people save millions of dollars by just using the Survey 123 out of the box to do survey in the field and inspect buildings, inspect facilities. It's a very easy to use app, and it really creates a huge ROI on any implementation. And people actually take it further by integrated with their existing IT tool systems and create a lot of things. There's also the field maps, another app for professional data collection. There's also quick capture, a new tool to quickly, you can have interns or your students or even before you don't have to leave your car and quickly collect some data like trees or location. These tools will help you really create that and bring all these data live to the field, to the office, and do further analysis on it. There's also the real-time visualization and analytics. You can look at all the data that's happening in real time, like tracking any kind of vehicles or drone maps or drones, or if you have ships or anything that has moved, you can drag them or track them in real time and do analytics on that. Traditionally, you probably have used the GeoEvent server, which is our enterprise, real-time analysis or visual analysis and visualization software. But now we have a new offering on the cloud. It's called the ArcGIS Velocity. This is a software as a service tool that allow you to massively track massive amount of events per second and do not just track them, but do special analysis on that. I can talk a lot about this, but better to show this. So let's welcome Yahya again, who is going to show us how the ArcGIS Velocity works. Yahya, please.
Thanks, Hossam. For the next 5 minutes, you are gonna experience New York City traffic in a whole new dimension. This is a custom web application designed to provide a live view of buses in Manhattan. We are looking at around 300 buses on 26 different bus lines, and we are using live traffic incidents to identify problems. This map of New York was created by applying a transparency to the buildings, as we see, so that incidents are visible through the buildings. If you look closely at the map, some streets are highlighted in red, indicating that cars are braking hard at those locations. When a bus is approaching such a street, an alert is created. If a bus is already within a street where cars are braking hard, a high-risk warning is displayed. These alerts are displayed on a map that would typically be in an operation center, and we can send these alerts directly to the driver console if we need to. The hard braking incidents are being detected in real time based on data coming from connected cars. We are working with our partner, Wigo, that uses connected car data to create incidents when multiple cars are braking hard on the same street. So, how do we analyze buses that are constantly moving with incidents that are also being detected in real time? This is ArcGIS Velocity, analytic behind the app. It's using two feeds. The New York buses feed provides real-time bus locations, and the New York City traffic feed provides real-time incidence locations. We are using a new feature in Velocity that lets you create dynamic geofences between features that are moving. This joint features function triggers provides an alert only when a bus is approaching an incident, and it recalculates the risk every time a bus moves, or if an incident changes. The true power of Velocity is that it can turn and run these computations on hundreds of buses and thousands of incidents in real time, allowing us to create a live view of the buses at risk. Velocity can also analyze historical data. So now we are seeing over the last 6 years, New York City averaged around 1,000 accidents a day. Although most were minor, they still cause bus delays. So we analyzed the data to identify the accidents on bus routes, and the map shows the location with most incidents in 6 years. There were 4,800 accidents in this area. And you can see the 5 bus lines that travel through this location. A temporal analysis shows the most accidents happened on Saturdays at 2 p.m., which is in this chart, shows that the number of accidents by time of the day and day of the week. You can see that bus operating in the park location were impacted the most, but we can also see this graph view of the operation. It's running ArcGIS knowledge graph that we demonstrated earlier. Selecting a bus that's operating in a real time selects it directly in the graph, and can expand this node to see who has driven this bus in the past, and if any repairs were performed. I can select a repair to see when it was performed and if it was a part of routine maintenance or not. And I can expand the node to see which parts of the bus were worked on. Because the graph contains both spatial and non-spatial data, I can use different approach and search for a driver. When I expand the node of the driver, we can see that this driver operated 4 of the buses and was involved in 3 incidents. And if I select one of the buses in the graph, it shows us where the bus is right now, connecting the graph to a real-time map as it scores and as happens. This application is about identifying potential problems before they turn into real problems of hard braking. One map of real-time historical and graph analytics can help organizations like yours make smarter decisions, benefiting from the real-time knowledge and temporal aspects. With that, thank you, and back to Hussam.
Thank you, Yahya. This is really a new, another exciting capabilities that shows the real time, but also I like that the fact that he showed the graph analytics. So we linked the concept of the graph analytics to the real time. This is very powerful. And that brings us this brings the power of the big data analytics on the cloud with the GIS and the graph analytics. So this is where concludes our first part of the briefing. We have another part coming soon. So, Lubna?
Yes, here I am. Thank you, Hussam, and let's thank the Esri team. Give them an applause. Thank you so much. Now we will go to the prayer break for half an hour. Let's come back at 12:30. We will be waiting for you.
السيدات والسادة الكرام، نأمل منكم الانضمام إلينا هنا في القاعة الرئيسية. نحن على وشك البدء. Ladies and gentlemen, please join us here at the main hall. We're about to start. السيدات والسادة الكرام، ندعوكم للانضمام إلينا. سنبدأ الآن. Ladies and gentlemen, please join us now. We are starting. حضورنا الكرام، نسعد بمقدمكم ونأمل منكم التفضل بالجلوس على مقاعدكم. سنبدأ الآن. Ladies and gentlemen, thank you for joining us. We're starting now.
أهلا وسهلا فيكم مرة ثانية. تقبل الله منكم. We're going to continue our session, the next session with Hussam again. We're going to talk about ArcGIS product. Welcome, Hussam, again.
Thank you, Lubna. Great, thanks. Okay, so welcome back. So we talked before the break, we talked about our capabilities, which, analytics, data editing, a lot of things that shows the power of the ArcGIS platform. Now we're going to talk about the specific products that actually make these capabilities available for you to use. One thing that just before we go, remember that all these software or pieces of product that we're talking about, they're all acting as one big platform. It's one comprehensive system that work together to provide or make these capabilities available for you. The first product that I want to talk about is the ArcGIS Pro. This is our flagship professional GIS desktop tool. Probably almost all of you are using it. That's where you can edit the data, you can build your own data, you can do all the editing, you can do the advanced analytics, you can make all this data available, or publish them and share them with your users. This is really the central piece of our platform. I mean, most of you are familiar with it. One thing that I want to say before we move on is that if you have the ArcGIS Pro, you already have access to ArcGIS Online. Remember before the break we talked about the web maps and instant apps and all these web mapping capabilities. If you have a license for ArcGIS Pro, you already have a license for ArcGIS Online and you can access that. So make use of it. If you don't have access to it, ask your administrator or talk to Esri Saudi Arabia to get access to that, but you already have it. So that means that you can get your data, you can use all the data in the Living Atlas that we talked about, you have access to that, you can use it in your analysis, you can publish it in your cartography products, you can share all this information with the public or share it privately with your own users. This is really important to remember that ArcGIS Pro has ArcGIS Online as well. ArcGIS Pro has multiple extensions. We talked about the 3D capabilities, the image capabilities. Each one of them is an extension. So there's a number of extensions that for the analytics, as I said, 3D analytics, 3D analysis, imagery analysis, network analysis. There is extension for data management and data interop and converting data formats. There's extension for doing production mapping, special cartographic mapping, topo map, defense mapping, all these bathymetry. There's a number of advanced and a lot of focused extension that allow you to further do more advanced things with the ArcGIS Pro. Again, we can talk a lot ArcGIS Pro probably need a month if we want to cover all the capabilities, but it's much easier to bring my good friend here, Ahmed Al-Awadi, who is going to show us what's new in ArcGIS Pro. This is a lot of new things here, so please pay attention. This is really an exciting demo. So Ahmed, the floor is yours.
Sam. So ArcGIS Pro is the most advanced GIS desktop software in the world. And it keeps getting better. We keep adding new features and enhancements. So I'm going to show you this in the next few slides. I'm very excited today to show you some of the many new enhancements that we added to ArcGIS Pro. So let's first start by looking at dynamic feature clustering. This is a map with data from Living Atlas showing all the major storms centroids within the past week. Dynamic feature clustering shows us where the data is most concentrated. And since clusters are dynamic, they will update as I change the scale. We can also vary the clustering radius to change the number of clusters on the map. And summary statistics can be added to show the average magnitude of the storms. Now, the map can be symbolized to show the number of clusters as well as their severity as well. Zooming back out to the country level, we can bring motion to our data and see tomorrow's weather forecast with the new animated symbols. Let me show you how easy it is to do that. This layer shows the active wildfire that started within the past week. We can access a library of symbols, and we can also add our own files, as I'm showing here. I'm adding my own symbology and increase the size to better visualize the active wildfire while the display is animated. Very cool with the animated. And at any given moment, I can pause my animation. Next, let's look at the new enhancements with big data connections. We can now connect directly to cloud warehouses, including Snowflake, Amazon Redshift, and Google BigQuery. Here I'll connect to Google BigQuery. Once I'm connected, all the data sets in the warehouse are available in the catalog pane. From there, we enable the feature binning to aggregate billions of records at different scales. So let's look at the severe storms over the past 20 years, revealing vast differences of the storm frequency across the whole US. I can also search my cloud data warehouse, bringing a query layer which performs a SQL query and returns only a subset of the data. In this case, I'm returning only flooding events with more than $1.5 million in property damage. Once the query is complete, the data is added to the map and ready for my analysis. Now let's go to Colorado. And here I'm going to talk about the data preparation. It can be a very tedious and time-consuming task. But the data engineering tools that we've introduced streamline this process, allowing you to explore, visualize, and clean your data as well. With the latest release, I can now add and calculate all the statistics in a single click, quickly calculating chart previews and summary statistics that help me better understand my data. Using the data engineering tools, I can quickly visualize the different attributes right on the map, such, for example, as the expected annual loss. We've also added some improvements to help ensure our maps are accessible with the new color vision simulator that adjusts to the map for different color vision deficiencies. Now I want to highlight some of the new spatial analyst tools. So let's zoom into the southwest of Colorado and to San Juan County, just south of the Silverton along the Animas River. This is a high-resolution digital elevation model from the USGS 3-depth program, which we will use to automatically delineate streamlines. In the hydrology tool sets, we've added 3 new tools: Derive Continuous Flow, and Drive Stream as line, and Drive Stream as raster. Taking a closer look at Drive Stream as line, we can input our 1-meter digital elevation model, set an accumulation threshold, and then let's see the results. Previously, pre-processing and hydro-conditioning required a lot of manual work to make your DEM analysis ready. But now this process has been much easier, so less pre-processing and less hydro-conditioning is necessary. Now that we've identified the flow lines that feed into the Animas River, we can zoom out to better understand the watersheds in the area. And now moving on to some of my best features in the new enhancements that we had in the ArcGIS Pro. And believe it or not, it's around the catalog enhancements. They make my life so much easier. Let's start looking inside the FileG database, which has more details than ever before. We can now visualize and sort by the last modified, as well as the size. That shows me that the weather forecast layer is my smallest layer, and also was last modified in July 11th. Also, if I expand my folders in the catalog pane, you can now see the name of the folder. It's complex and long. You've always wanted to change this, but because you didn't want to break the data source, it was impossible to do that. Now it's easy to do that because you can create an alias like Colorado Watersheds, for example, without changing the underlying name. Next, moving to the home page, we've enhanced it so much, and a lot of you have been asking for these improvements. It starts with easy access to all the learning resources available for you. Also, the project management have been streamlined. You can now search for a project, pin it, and it's promoted to the top of your list. And when we sort our projects, the pin product stays at the top. And to see where that project is located, I can now directly access and launch where that file physically is located. A lot easier than before. And lastly, let's head to Dublin, Ireland, and take a look at some of the new enhancements with the BIM integrations. Here we have a mashup of content from BIM and CAD that combines infrastructure from Revit and Civil 3D with additional files from Collada as well, all combined within my GIS layers. And now with the latest release, we support both Revit and IFC files related to the infrastructure, like what you see here with Samuel Beckett Bridge. The bridge known to rotate 90 degrees in just 3 minutes, and we can visualize every step of the rotation. All of these enhancements and many more are available for you to use and explore. Thank you so much. Back to you, Hussein.
Thank you, Ahmed. This is, again, very amazing. I really like this bridge and 3D, bringing BIM inside the professional GIS. This is your digital twin in action, really. We can talk about it, but this is real stuff. All right? Next, an equally exciting product we have is ArcGIS Online. And I remember when my first time I did an ArcGIS Online demo almost about 12 years ago, and comparing that to what the capabilities you're going to see now, it's way ahead. It's have advanced a lot. So ArcGIS Online is really a comprehensive GIS system available as a software as a service. It's on the cloud. A lot of the time, you can use it in doing advanced analytics. You can do it and use it in imagery processing, as you see. Recently, we have the ArcGIS image extension for ArcGIS Online available. There's a lot of things you can do with that, and millions of users around the world are using it and sharing really millions and millions of data, apps, and story maps around the platform, around the world, and sharing it with the public. This is a very easy and cheap way of accessing the public without having to spin off very expensive infrastructure and make them available to extend or work with all the demand from millions of users. And the Johns Hopkins, dashboard is a big example of that. It was like millions of hits every day, and the ArcGIS platform could handle that. We can again talk a lot about this, but it's better to show it. So welcome Yahya again to show us all the new things in ArcGIS Online. Yahya?
Thanks, Hossam. Once again, I'm today excited to share a countdown of my favorite new features in the ArcGIS Online. Let's start the countdown with my number 9, the Living Atlas, with 3 recent enhancements. We have added a global 3D data set of buildings and streets using OpenStreetMap. Now, you can visualize anywhere in the world in 3D, from Istanbul with these towering mosques, all the way over to a little town in the US, Austin, Texas. Seeing it all in 3D. The Living Atlas also have hundreds of readily available imagery layers that are updated frequently, including from the Sentinel-2 satellites. This dataset has a global coverage and a 5-day revisit rate at 10-meter resolution. And how we have added support for on-demand rendering just now. Let's zoom in the recent Black Fire in New Mexico, where we can use this imagery for the fire by using color infrared to visualize healthy vegetation and shortwave infrared to better visualize burn scars. And now you can view recent and historic satellite imagery anywhere in the world, because we have added this entire Sentinel-2 archive to the Living Atlas. We have also added the US federal government. Second here. Sorry, with this, let's move to number 8 on my top countdown feature, which is happening in San Diego, the 3D Scene Viewer, exploring some recent enhancements to the Scene Viewer that enables you to create a more immersive experience. This scene is using a 3D mesh from Aerometrics, which is one of our partners. And now let's add in the new weather effects with some clouds and rain. And if you like, even a little fog. Next, let's move through the fog to the construction site for the new San Diego State University football stadium for those football fans, where we can even visualize feature development by bringing in BIM models like this one from Clark Construction directly into the web scene. All right. At number 7 in my countdown, enhancements at search. So let's search for some content about protected bike lanes. And I'll go ahead and choose one of the layers for Washington, D.C., which is this one. Now, without leaving the page, we can view attribute information quickly, giving us a detailed information we always want to know when we are searching at the same page. For number 6 on my countdown, let's explore our new web editing experience. Zooming in on a recent development along the Southwest waterfront in Washington, D.C., we are using data from Open Data Hub to visualize areas under construction in beige. Now, you have asked for an enhanced web editing experience. So let me introduce you to the new feature to feature snapping and the new geometry guides that enable you to quickly and accurately create data in web like this pedestrian zone. For all you editors over there, if you like that one, I think you may like the next one as well. Enhancements to attribute editing. At number 5, we have implemented powerful tools like domain-based drop-downs and conditional rules. So as you make selections, the form automatically updates with the correct fields to enter. We have also added the ability to auto-calculate fields, like the amount of cubic materials needed, that automatically adjusts as you change the depths field. My number 4 in the countdown is all about helping you make decisions at a glance. Enhancements to the new ArcGIS dashboards. This dashboard is monitoring the status of bike share stations across Washington, D.C., and which a recent release of ArcGIS Online benefits and allowed the download of features. So now we can see this downloaded data directly from the dashboard in CSV file. Number 3 on my counting down is the support of Arcade inside the ArcGIS dashboards. At the bottom of our dashboard, we have a table widget where it's challenging to prioritize need across our network of bike stations. But with simple Arcade expression, we can easily add this icon to the next to the station and calculate our weekly trending usage and highlight any stations that has low bike supply and seen as uptaking the usage. This is just one example of how using Arcade within the ArcGIS dashboards. But it really can enable you to make more decisions at a glance and quickly prioritize the limited resources. My number 2 item, bringing static data to life with flow style rendering. Flow styling visualize imagery layers like this ocean currents data that's showing sea surface temperature and flow direction, enabling you to grasp patterns and trends like the warm waters of Gulf Stream traveling up the east coast of the US. Now, reaching number 1 item, special effects. Let me show you 3 examples of how special effects can turn your data into stunning maps. First, let's use blend modes on this county level air quality data to visualize blend data together, like here, where we are adding the terrain. Next, layer effects like drop shadow enables you to quickly add a finished touch to your web maps. But the power of these effects really shines when you can target your data by creating feature-specific effects, where as we adjust this histogram, we can interactively explore the data, emphasizing counties of poor air quality, while de-emphasizing the rest. With these special effects, your users can easily grasp patterns and trends and interactively explore data. Now, let me show you some stunning, vibrant web maps, focusing on conflict in a specific country, showing underscore the breadth of watersheds with drop shadows, and highlight human pressures on habitat loss. With all these special effects, it was never been easier for you to turn your data into a beautiful map. That's my top new features in ArcGIS Online, and there was a lot more for you there to experience and find out. With that, thank you, and back to you, Hussam.
Thanks, Yahya. This is, for me, for old-timers like me, this is amazing. Have anybody remember the old AML and ArcGIS, the very old products, AML? Anybody? Oh, here's 1, 2, 3. Do you remember how many lines of code you need to create something like this, if it's possible? And I remember like 25 years ago, I used to lock myself in one room and write almost 1,000 lines of code just to produce a map. Now, on the web, not even the desktop, on the web, with few clicks, few parameter changes, you can really have an amazing map. This is really astonishing. For GIS people, it's like it's like a kid being in a candy store. It's amazing. Great. So we talked about ArcGIS Online. As we mentioned, ArcGIS Online is a comprehensive system and have multiple extensions. We showed the image extension for ArcGIS Online. We showed the velocity that is also indoors, but also one of the extensions is called the ArcGIS Hub. And this has recently been widely used to really create astonishing landing pages, creating pages for sharing your data, communicating with your people, especially the citizens, communicating within your own organization and talking to them. It's really like a template and a web designer to create good-looking web pages that has geospatial data inside them, whether maps, map galleries, story maps, dashboards, surveys inside. You can bring all the different components of the platform within easily drag and drop ways to design a web page. So a lot of the people who are, the organization can use this to create their own page to share the data with the public or within the organization. We've seen a lot of organizations like Gasky and other mapping agencies use that as the main way to share their data to everybody. But not just about sharing data, but this concept of initiatives that you can actually create an initiative, and there's a lot of templates for creating initiative, and you can use that as a way to collect information, interact with people, reach out to your public and the users, and get more information about surveys, their communicate information about the location of your facilities, getting feedback from them. So this is a way that has a lot of existing templates that you can easily create these good-looking maps and web pages, sorry. The other central piece of the ArcGIS platform is really the server component, or what we call now the ArcGIS Enterprise. That's where is the heart of the platform. That's what, serve everything that we saw so far. The astonishing 3D, the image capabilities, the 3D, the editing, all these things can be served to multiple users using the ArcGIS extensions, ArcGIS Enterprise, sorry. And you can have that on your own servers, as a lot of you already do that, or you can actually deploy it on the cloud, like the Azure cloud or Amazon cloud, if you don't want to manage your own infrastructure. So this is the professional server tool that a lot of you are familiar with and host and power all of these capabilities we have. And it has many extensions, like image extension, geo-event for real-time handling. And also one of the things that a lot of people don't know, there's a monitor extension for the IT admins to monitor the safety and health of the server and see how the services are doing. If anything is down, it would immediately alert the admins so they can do actions. There is a workflow manager for managing all the workflows and editing your data and doing spatial analytics. There's a lot of things you can do with the enterprise around data management, about visualization, about analytics, and sharing and collaboration as well. One new product that you can actually have ArcGIS Enterprise in a different flavor of deployment. Anybody using Kubernetes here or familiar with Kubernetes? One, two, okay, yeah. Few people understand. So Kubernetes, if you're not familiar with it, you can think of it as another kind of operating system on the cloud. If you used any of the cloud, like the Amazon and Azure, and maybe you heard about that you can put an app there and it will automatically scale. Like if you have an app that just 10 people using it, okay, it's going to have one instance. If you suddenly have 10 million people, instead of having 100 servers, the cloud will just immediately scale up to this and work with these clouds. This is all behind the scene work on this concept, this Kubernetes. Kubernetes works with something like, in a very simple way, getting a very sophisticated piece of software like the ArcGIS Enterprise, divided into smaller microservices. You see in the middle here, this is what we call the ArcGIS microservices. So a small piece of software or a microservice for data editing, another for special kind of analysis, and so on. I'm trying to simplify it. So these services work independently and at the same time collaborate together. All these handled by the Kubernetes, and they can scale up needed. So if your user is accessing your software and do a specific analysis, and suddenly you have 100 people doing the same kind of analysis, Kubernetes can spin off multiple microservices that are addressing this request. So it will automatically work with you, and this is really loved by all the IT people who have their own private cloud, or even in the public cloud they can do that. So Kubernetes is one way to deploy ArcGIS Enterprise, especially for the very sophisticated organization that want to easily scale and address multiple users, and they have their own cloud. You can use this. Now it's available on Azure, and it's also available on the Amazon, and we are adding more and more microservices to it. Another capability is the ArcGIS GeoAnalytics engine. So again, Saudi Arabia is one of the pioneer countries around the world, so a lot of you worked with us with the early versions of that. It wasn't a product yet. There was a research and development effort to work on big data. Imagine, for example, one of the telco companies. They have literally billions of records of data of location of users, and they want to analyze that and find out where are the shortage of the coverage. That is not possible with your ArcGIS Pro or your traditional GIS analysis tools. You have to do different kind of technology. So we used to do that on big data. We used to do on Hadoop, and we have to work on Hadoop to do these analytics. Now we made this a product, which is called the GeoAnalytics engine. In a very simple way, GeoAnalytics engine allows the spatial analytics to happen on huge amount of data, billions of records. And to make this happen, we cannot download all this data to our desktop or enterprise professional GIS to work and then work on it, because it's going to take days to download. It's the opposite. We actually bring the analytics, the algorithms of doing the analysis, bring it all the way to the data on the cloud or on the big data tools like Hadoop and others. And then perform this analysis there, get the output of that, show it on any of the platform component. Again, I can talk about this, but it's better to show it. So please welcome Ahmed again to show us how this works. Ahmed, please.
The United States has a population density that varies from major cities to rural areas, and this varying distribution often creates challenges for high-quality cellular coverage. No doubt, some people have experienced a loss of signal at one point or another. So let us show you how we can use big data analytics and data from our partner Ookla to better discover areas that may be underperforming. The Ookla Speed Test app is designed for anyone to test internet speeds on their mobile devices and provides anonymized background sampling data from Android every 15 minutes. These reports have more than 100 different attributes that are measured, including network performance, provider name, time, and location. Now, a sample file from Ookla for a particular day contains tens of millions of records. So large, it's impossible to open with a spreadsheets application. We're talking really big data here. What we can do to handle this volume of data is leverage the power of distributed processing with Spark in big data environments. Here is our Spark cluster in a cloud. In this case, we're using Microsoft Azure Databricks. By allocating multiple nodes in a cluster, we can execute big data queries quickly. To get started, let's hit Run to read in more than 300 files from Ookla's data store. We see that we have about a year's worth of sampling points, which is well over 4.5 billion records, as we'll see over here. But to discover where bad coverage is, we need to do spatial analysis. And that's where the ArcGIS GeoAnalytics engine comes in. Simply dragging in a jar file gives users access to more than 100 well-documented spatial functions, native to Spark SQL, and various geoanalytics tools that are accessible through PySpark. These functions are installing as we speak. And once that is done, they can also be very easily imported, as I'll show right now in the code. Just like this. Now that we've brought in those spatial functions to the data, we can begin our analysis. First, let's visualize the data by aggregating these points into 50-kilometer hex bins that show the average cellular coverage for the entire US. In just a few seconds, we're able to aggregate all 4.5 billion records worth of data into just over 6,000 hex bins to create this map, showing network coverage from poor in red to excellent in green. Next, to visualize the statistically significant gaps in our data, let's cluster this data using the density-based spatial clustering tool from the geoanalytics engine. What this does is reduce our areas of poor coverage to only a few locations within the US. To better understand what might be contributing to these clusters, we can also easily share our results to ArcGIS Online and take a closer look at these points in a web map. As we zoom in on this red cluster in southern Oregon, we discover we're in a rural area with national forests and wildlife refuges. This may give us additional insights into the poor access to cellular coverage in these rural areas. Now let's take a look at a second analysis that focuses in on coverage along these major highways. Using a user-defined function, we can create a custom spatial operation, such as aggregate coverage values at set intervals along roads. This fully leverages the Spark cluster, helping us to focus these data points into hex bins along roads and highways. We can see our final results in this web app, highlighting which roads have good or weak coverage. Also, these aggregations can be filtered in many ways. For example, to better understand the digital divide, we can overlay these hex bins with the Justice 40 tracks, which show disadvantaged communities with poor coverage, or by overlaying federally recognized tribal lands, or even areas of high cellular coverage to help network providers further prioritize their investments. The ArcGIS geoanalytics engine brings the power of spatial analysis to your existing big data infrastructure, helping analysts make sense of it quickly and easily. Thank you. Back to you, Hassan.
Thanks, Ahmed. Thanks. This is a new capabilities really allow you to do things that you cannot do with your traditional GIS. Great. For you who have billions of records, you can easily work with the ArcGIS geoanalytics engine to do some traditional GIS analysis on really billions of records. This is another great capability. Next thing that I want to highlight here is one of the things that a lot of you are not familiar with or probably not using. Part of the platform, there's a lot of templates and that available online that you can download and use, and which we call ArcGIS solutions. So what are these? These are a number of focused applications, whether web or mobile, or sometimes dashboards, or sometimes configuration of your ArcGIS online that focus around specific use. So we have a number of these ArcGIS solutions around land records and around the public works. There's really, I mean, I can't even count them. There's a lot of them. You need to go there to arcgissolutions.com and see which one you can use. But there's a lot of things about transportation. A lot of the traditional workflows that you might be doing in public safety, for example, if you want to manage event, or telecommunication, if you want to do analysis signals. A lot of these traditional common workflows, you might find a template that fits that. So instead of you going and trying to develop a custom app or configure a dashboard for that, you might have it already something that you can start with and maybe further enhance it to fit your 100% of your needs. But these solutions, the good things about them, they're available for you free of charge. You can download them, use them. They work with the platform, and they are supported as products. So you can, if you have problems with that, you can call the tech support, and they will give you support for that. So this is a lot of the time, it's something to provide quick wins and easily start your platform and provide immediate benefit for your users. So I encourage you to really look at that. Another product or a piece of, or a number of products that you can use if you want to just build something that looks like a custom app that or fits your needs without really writing any line of code, or maybe writing few line of codes if you have these capabilities. I think the web app builder have been there for a long time, and many of you use this to configure web apps that looks different and looks like they are fitting your need and looks like they are custom built for them without really writing any line of code. There's millions of people shared a lot of web apps using the web app builder. So this is like a browser thing, and you drag and drop widgets and put them on there. If you have developers, you can actually create your own widgets that just actually perform more sophisticated functions. Or you can use one of the existing templates and build a web app very quickly, starting with a web map, of course. The new generation of this, and maybe some of you don't know that, the new generation of the web app builder is called Experience Builder. So the web app builder has been there for years. It has the slightly older RJS JavaScript SDK. The Experience Builder have the newest one. It has all these latest capabilities of the 3D rendering and the capabilities we've seen. And you can actually drag and drop and design the web app using a lot of existing tools and components, and you can actually develop your own piece or component within the Experience Builder if you have a developer or you know how to write code yourself. But this is the next generation, and whatever you create, it's optimized on different devices like the tablets or the mobile. It's all responsive design. The third piece of that is the App Studio, and that's been there for a long time also, and it works. If you want to create a native app without having to write the code for iOS, for Android, or others, or you can actually use this to drag and drop or use an existing template or build your own components. We use one of the existing SDKs, and then compile it once for Android, compile it another one without changing any of the code for iOS. So you write the code once or configure it once. You compile it multiple times for each device. So that will create a native app for based on what you want. That's also a quick way to create some of the common workflows as a native app. But if you want to do your complete custom web app or mobile app or an app that runs on tablet, you can do that. We have all these SDKs that can allow you to start from existing code or actually write from scratch if you have a sophisticated need or you're integrating with other system. So you can extend that. You can start with the Python API, which is very powerful for automation and handling the machine learning and AI algorithms. You can do the enterprise SDK to customize the enterprise. You can do JavaScript API if you want to create your own web app. A lot of the map viewer capabilities you've seen with ArcGIS Online is already built using the JavaScript API. So a lot of these things you can actually do and create your own custom app. There's also the mobile SDKs for creating native apps on iOS or Android. A lot of things you can do with that. So it's really, the platform has a lot of tools, capabilities out of the box, but it can go all the way to creating completely custom app using the basic components of the GIS platform. And one of the most popular SDKs we have, or APIs, is the JavaScript API, which allow you to do rich web applications. You can do data-driven visualization, you can do editing, you can do 2D and 3D visualization, advanced also analytics. And as you've seen many times in the demos, the performance now is amazing, whether on the 3D or the 2D, because of the advanced and the latest JavaScript API. You can experience that if you know how to write code or you have a developer that can use all these tools. Now I want to talk about another thing, which we call the ArcGIS-enabled systems. So these are focused applications or pieces of software for specific use. We have what we call ArcGIS Urban for urban planners who work in countries, which we have a lot of them here in Saudi Arabia. We have all these big projects. So this is something you're going to be excited about. We have a demo about it very soon. We have the GeoBIM capabilities, which allow you to work with BIM and GIS. We also have another demo coming soon about this. There's the indoors, which allow you to go and work inside the building and see your data and manage the facilities. There's multiple things, City Engine, and one of the ones is Excalibur. So what is ArcGIS Excalibur? I'm not going to talk too much about it because we have a demo coming very soon, but it is really a web-based tool to do image exploitation, which is really looking at the image, searching, discovering, and finding new information by analyzing the imagery, and then sharing the results within the organization. Who can use that? How to use it? I'll let this to Jack Eats. This is our young Jack, not we call him the Jack Jr., not the big Jack.
Thank you, yep, thank you,
Jack
Hossam.
is going to talk to us about the RGS Excalibur. Please, Jack.
Great, yep, thank you. So RGS Excalibur is a focused web application, and it's been fundamentally designed to do two distinct things. The first part of this is it's your search and discovery. So if you've got a massive imagery sitting somewhere, you've got terabytes or petabytes sitting on a server, this is the interface you use. You can go in, access that, and pull back the relevant imagery services and tiles to you. So that's the first part. The second part of that is, once you've got those services and those tiles, you can then exploit them and get actionable information from that imagery. And we'll go in and have a look at this now. So Excalibur gets launched. It's a web application from Portal, and I can go in and I can see the imagery that's available to me. And these are all services coming in, various sensors, various geographies, all from my federated image server. Of interest to us, however, is we've got some aerial imagery of the west coast of California supplied by Planex. And so this is the search and discovery part. You go in, define your area of interest. In this case, we're interested in San Francisco, and in particular, the Golden Gate Bridge. And it's returned to us those footprints and tiles of imagery that meet our criteria. And in particular, we want to have a look at these four. We can preview those images. And this one appears to be a good fit. There's no cloud cover. And we can also have a look at the metadata within that, the time of day, the sensor, the resolution. So that's the first part, the search and discovery. And we're now moving into exploitation. We can immediately see there's a problem. So it's been captured from an oblique angle by that aerial sensor. So it appears skewed and stretched to us. If we look at the buildings, particularly in the center of the screen, you see they appear unfamiliar. What we can do, however, is have a look at a different view. So instead of the top of the map being north, the top of the map is now the direction the sensor captured it from. You can see how much easier it is to interpret the right-hand image versus the left. Again, we've got other imagery within here we might want to have a closer look at. In particular, we've got some panchromatic high-resolution imagery supplied by Digital Globe. And we want to go in and make a quick assessment of the economic activity that's been taking place within Oakland Harbor, within San Francisco Bay. We've got our map view, but we also want to have a look at this within image space. So we've got multiple ways of looking at this and interpreting the imagery. And if we go into Oakland Harbor, we've got some very basic commensuration tools to allow us to go in and make a quick assessment of the economic activity. We can quickly run an area or define the area and get the size of it to infer the number of ISO containers that can be offloaded. We could also measure the length of the vessel to try and identify which vessel this is. Or we can even measure the length of the shadow. We know the time of day this imagery was captured, so we can see it's about 34 meters high. And this is when, as an analyst, I begin to go in and start to mark this up. The key point to make with Excalibur is this is a web capability. This isn't ArcGIS Pro, which I'm sure you're familiar with, and the tools within that. This is for a casual user to be able to go into the web and do this at an enterprise level. The idea being, he's got most of the functionality that he needs, and indeed, these simple workflows cover about 80% of the functionality an image analyst would need to do his day-to-day job. Again, because it's at enterprise level, it's in the web tier, you can share this. All this information is no use existing in a silo. You want to notify people in your own agency, other agencies, about what you found. In this case, I annotated that there's been a large uptick in activity. There's a lot more economic activity taking place in this port versus the start of the month. And I've got a few different options for me to go in and start to share this. I could simply take a snapshot of the image itself, or I could create a basic report, so I can there share that soft copy on the PowerPoint. I can annotate a bit more information in this, particularly about the information that I found as an analyst. And as I turn that into a report, I've also got the option of adding this as an item to Portal, so then it exists in the web. Everyone else using the enterprise system can access this over a simple URL. And as well as the map, we also have the metadata itself. It's very simple workflows, but hopefully you can see the value of Excalibur. It's intuitive, it's easy to access, it takes place in the web, it's for your casual GIS user, and also this is the interface you can use to perform search and discovery on your large-scale imagery catalogs. Thanks.
Thank you, Jack. This is a focused app for the image analyst. This is really creates a lot of easy tools to use. I never imagined that just the, a small capability like reorienting the imagery to a certain direction is very important to the image analyst. So they really appreciate that. If you're working in this field, you will appreciate this kind of product. Next, another focus product is the business analyst, and it's been there for a long time also, and many enhancements in it. The ArcGIS business analyst is mainly used by a lot of the commercial companies to do site selection, market analysis, competition analysis. It uses a lot of the existing demographic data and data available around the world, but also you can bring your own data, competition data, your own market research or market analysis data, and do a lot of these business analytics to find where is the next Starbucks to open, or where is your next store, or is your store doing well compared to competition. There's a lot of things you can do, and it's all part of the ArcGIS platform. So this is another focus app. Another thing that is really, really close to heart here is ArcGIS Urban. I really wished if we have this in school back then. I'm an architect by training, so I studied architecture. So we used to do all these things manually, but if we had these tools back then, I think we had a lot of fun. So I'm really envious of all the students now. ArcGIS Urban is really designed for urban planners. It's really allowed them to do different kind of analysis of the different alternative of rebuilding or building a new city or changing the urban structure of a certain part of the city, to allow you to do suitability analysis, and allow you to experience different scenarios and look at them, evaluate them, and then allow you to communicate to the others. There's a lot of things you can do that. Now, we can talk about it, but this kind of app, you better see it. So the best one to talk about it is my really good friend here, Jessie Hansen McFarlane. She came all the way from the US to show you the ArcGIS Urban and talk to you about it after this. So Jessie, please show us the excitement.
Thanks, Hossam. It's an honor to be here. So ArcGIS Urban contains plans, which are long-term land use and policy initiatives, and projects, which are short-term proposals usually submitted by a developer or an architect. This short example is from the municipality of Karlskrona in Sweden. When I open the plan, you can see a series of tools that enable scenario planning in context of their 3D city model. Changes can be made to the underlying policy zones, such as a maximum building height. Users can also create alternatives to the buildings themselves, such as looking at changes to land use, the number of floors or units, or making a building taller or smaller itself. These changes are managed across scenarios, so you can simulate both a high and a low exploitation of a site. You can also experience a street view and compare what is being proposed versus what is there today. Advanced spatial analysis, such as viewshed and shadow analysis, is now becoming more accessible in the web browser. For example, simulation of shadowfall is critical to ensure good microclimates on the ground. This analysis can be explored across scenarios to better understand the trade-offs. A more detailed project submission can also be uploaded, including with BIM data, and can form the basis on which we can collaborate and review proposals, comment on those proposals internally, and share this feedback directly with the developer or architect. Next, I would like to highlight one project our R&D team in Zurich is working on. This project is focused on pulling planning and scenario content from ArcGIS Urban into game engines. This workflow enables you to create and experience walkthroughs of what is being proposed, allowing you to experience your data in new ways, and adding details like weather effects to understand real-world factors. We are designing an intuitive user interface that can be used either with a VR headset, like the Oculus Quest, or through the desktop, which you might use over a screen-sharing application like Teams. The tabletop experience is a useful way to explore a digital twin of your city. We are also working on a collaboration mode that will allow multiple users who are in different physical locations to connect in this common virtual location and experience the model together. Together, stakeholders can dive into detailed projects and plans, like this plan for the city of Boston. Here, we have a plan that has pedestrian and car simulations, in addition to dashboards that reveal the metrics of the plan. This R&D effort is opening the door to innovative and immersive ways to share, understand, and collaborate using a GIS-based digital twin. I hope you are as excited as we are to experience this new capability. Thanks, Hassam.
Thank you, Jesse. This is great. I can name at least 4 or 5 organizations here in Saudi Arabia that are either waiting to implement this or are already planning to implement ArcGIS Urban. With all the mega projects going on, this is the product for you guys. So really exciting. All right, an equally exciting thing is, as I said, everybody talk about digital twin. Few people are actually implementing it. But one of the things that can make this happen is the product called ArcGIS GeoBIM. We talked about this a little bit. This is the result of the strategic relationship and long collaboration with Autodesk. We worked together, our developers worked with the developers of Autodesk for years, and we created this product, which is really allow you to access all the BIM data from the Autodesk products, like Revit BIM or other products, and also avail the GIS data within or from within the Autodesk tools. I don't want to talk too much about it, but we can wait for Rafael to come, okay, until he comes. So now, this is part of the ArcGIS platform. It's available on the cloud so far. And you can work with, if you are already implementing Autodesk products and you're using it to manage the BIM, you can easily integrate the platform within that. Now, Rafael, so the best one to talk about this, again, another person all the way from the US coming here, Rafael Lucero. He's the expert in GeoBIM. So, Rafael, please show us that.
Thank you very much, Hassam. Great to be here. So as many of you know, building sustainable infrastructure is a complicated process. Critical data supporting project development is often hosted in multiple systems, making access to information difficult for decision makers. ArcGIS GeoBIM can help with that. GeoBIM links projects and workflows by interconnecting ArcGIS with the Autodesk Construction Cloud. You can create GeoBIM projects that link ArcGIS features to Autodesk documents to support integrated visualization and improve project delivery. So let me show you an example of this. This is a light rail project in the greater Denver area. So typically, a GIS is used in early assessments to see how developments like this are affected by both the natural and built environment. And then we have the Autodesk Construction Cloud. As we move into the design and construction phase, the Building Information Modeling, or BIM, process is introduced. So we can store our asset models and files here and build them collaboratively. Apologies. sure what happened.
All right, some technical difficulties.
Can we fast forward?
So until we see what's the issue, how many of you are actually working with BIM data? A few hands in the back. Oh, actually, a lot of hands here. I can see that. Cool. So which tools are you using to handle the BIM? Anybody using Autodesk? Other tools? Yeah, I can see. Yeah, few people. Good, good. So hopefully this can be helpful for you. And as I said, we have Rafael and Jesse here available today, tomorrow. We can talk about it, about digital twin, about ArcGIS Urban, because I know there's a lot of people interested in that here in Saudi. All right, looks like we're back.
I think we're back in action.
All right. Thanks, Yahya, for the rescue.
All right, so here we were seeing the Autodesk Construction Cloud where you can store your documents and build them collaboratively. So the Autodesk Construction Cloud manages engineering plans like what you're seeing here that are going to be used through the entire project lifecycle of the project. But you can also use the Autodesk Construction Cloud to track and manage your design construction issues, store engineering specifications, as well as documents. Now, what we're seeing here are two distinct and separate worlds. So let me show you how ArcGIS GeoBIM brings these two worlds together in a single app. So what we're seeing on the left is ArcGIS, which includes our base maps, our infrastructure layers, and our building scene layers. Here, I've highlighted a rooftop air conditioning unit. Now, on the right, what you're seeing is our Autodesk Revit model of this mechanical system. And what we can see here on the Autodesk Construction Cloud side of things is the full route of the ductwork and the design. So GIS and BIM are shown side by side to help with critical coordination of these detailed systems. We can also do this for Autodesk Civil 3D models, as well as AutoCAD files and IFC. So when I select my rail feature, I can then open up my link and begin to see this work-in-progress infrastructure drawing that can be shared with the full project team to improve project collaboration. Now, through GeoBIM, we're bringing together this wealth of BIM and GIS data to improve coordination among the full project team. So let me quickly show you how we can link GIS and BIM in the GeoBIM Project Manager. And we first start by creating an account connection to the Autodesk Construction Cloud. And next, I'll head to the tools, where you can automatically create links between GIS and BIM. So you select your engineering documents, you select your issues, and GeoBIM will then begin searching your Autodesk project folders and begin creating boundary features that link back to the original design files. Now, this linked information is useful, so let me show you how you can create apps. Within the apps page, we can create several different types of applications, including those for documentation review, for site context evaluation, and design and construction coordination, among many, many others. And finally, let me show you the issues dashboard, which is useful for project managers and executives who need to understand and monitor project progress. So we can also understand where these issues are occurring across the project and across the program portfolio to get transparency into the whole project lifecycle for everyone. So as you can see, ArcGIS GeoBIM provides a foundation for your projects, whether you're an AEC firm or an owner-operator. You can simplify team collaboration and put your projects on the map. Thank you. Back to you, Hassam.
Thank you, Rafael. This is great. So now we can see how we can combine both worlds of BIM and GIS together. This is great for the people who are working with project management, work with building or designing buildings or urban planner. This is a great tool. Okay, moving on to another focused product is ArcGIS Indoors, which really allows you to manage your indoor facilities. A lot of you here in the Saudi also implemented that. This product is available for you to work with your indoor facilities, manage the space, work on the work on this on the different experiences, whether on the web or on your mobile devices, finding your way around. Another complementing product is what we call ArcGIS IBS, or Internal Positioning System. This is like bringing your GPS, traditional GPS, but inside the building. So bringing this blue dot that you usually see on your map viewer when you are traveling around the city, bringing it inside. So think about it if you are in a big refinery, complicated system, and you want your workers to know where they are and you want to monitor them, because where they are can affect their safety. So IBS is very important for that. Or for in a hospital, like, for example, this is something that you can use. This is all done by placing beacons, Bluetooth, low bandwidth or low power Bluetooth beacons in specific areas, scan the location, calibrate that, use them to create signals, and then create the 3D location inside the building. And you find out where you are, and you can navigate through it, you can find your way around it. This is also part of the ArcGIS platform. Another focused app, which is really used, can be used by people who handle events or look at the safety of events, or have people deployed, teams deployed in the field to do certain things, or a mission. That's why we call it ArcGIS mission. So law enforcement agency, they can use it to deploy the crew on the field, find out where are the crew, what are they doing there, tracking them, communicate with them. Any security operation, whether in the intel or defense, can use that as well, or the public safety officer can use it. They can chat with each other, or through a number of apps, an app called chatting and finding the location as well. They can report where they are, and the office or the officer can track where they are. They can actually find incidents and report that. All this can be managed through the ArcGIS mission. We can talk about it, but it's better to see it, so please welcome Jack again to show us how the ArcGIS mission works. Jack, please.
Okay, thank you. So most of you will be familiar with our mobile applications. So things like Survey 123 and Field Maps, and even Workforce to be able to manage these apps. And the way to think about ArcGIS mission is it's really taking it one stage further than those applications. And the use case for this is when real-time information is critical to the work you're doing. And this could be in a few different ways. So if you imagine you were having to monitor the traffic build-up in Riyadh, and you had to monitor that situation. Or maybe you had security personnel you were having to manage for an event such as this. Or potentially, and the example we'll look at, is having staff managing and monitoring and responding to a large-scale oil spillage along a pipeline network. And that's what we'll look at now. So again, ArcGIS Mission, it's another application in Portal. We launch it in the web tier. We can go in and have a look at the missions that are live and have already been configured. And in this case, we've got a mission set up to monitor the Keystone pipeline system in the southern United States. And just for a bit of a background on this, the Keystone system's had several high-profile spillages within the past decades. The most recent of this was actually about 5 weeks ago, and around 14,000 barrels of crude oil was spilled into the local environment, only about 5 weeks, and did significant ecological damage. So in this case, this is me as mission commander monitoring my staff to be able to respond to an incident like this. I've received information from the general public. There's been a potential spill in this location. I can mark it up and start to assign this as a task to my field workers. You can also see the field workers themselves along the left-hand side of the screen. And I've also grouped these into teams, which can be managed through the same interface, as well as I can give them any documents, PDF, Word documents, potentially emails or photos, anything the guys need on the ground to be able to do their job. Likewise, of course, we're a GIS company, so of course we have geographic data. We give them the center line of the pipeline. We give them the release points. We give them any local civil defense stations, anything they need to aid in the cleanup operation. Now, once I've got my staff, I can see their live location in the field, and I can see down to the status of what their battery level is, and even the tracks that they left, much like ArcGIS Tracker. And, of course, I need to be able to talk to them. So we've got real-time chat and real-time communication that lets me communicate with them over the 3G network and say, okay, we've got a potential spillage, go to that location, but also I can keep in communication with them at all times. So this is now, I've sent the message, and the guy out on the field has got the mobile device, he's received this, he then navigates to the place where the potential spillage is. Once he's found what it is, he can make a quick assessment, he can potentially take a photograph, or as in this example, we could mark up the access point, so we've got that as geographic data, and let the rest of the team know how to enter that potential spillage. And as well as marking it up and sending the data, he's also in communications. He can communicate back with the control room, and he can communicate with everyone else that's on the mission at the same time, or even by specific fire teams. And you've got that ability. Again, one of the key takeaways from mission is that all this information is saved. So your live chat, the tracks left by your workers, any data you create, it's all saved in the database, and you can use that for post-incident analysis. As well as historic data, we've also got the situational awareness viewer, giving you that live view from the field. You can see the status of your guys working on the task. You can see the status of the incidents yourself, and it keeps you up to date with what's happening. So that's just a very, very quick and simple example, but hopefully you can see how mission can be leveraged when the work that you're doing has a time-critical element. Thanks very much, and Hossam.
Thank you, Jack. That was great. It's another focused app. You can use it if you're having missions. You can handle that. So that actually the final demo we had today. So we conclude our presentations. And you see, all the Esri team is available here today and tomorrow. A lot of us have sessions tomorrow. So please make the use of our time. So, and stop by and ask us any question you want or discuss any of things. So, Lobna, please.
Thank you. Thank you, Hossam. Hello, everyone. It's the end of our day. Thank you all for being here today. I hope you enjoyed the journey with Esri, from having an amazing opening with Jack to learning more about ArcGIS with the Esri team from Vision and ArcGIS products. For me, I enjoyed being here with you all. I would like also to thank Esri team and everyone who worked with us to make this event. Please applause for them. Thank you. I would like to invite you for the food in the next room. Please serve yourselves. And I hope we will see you tomorrow, as there are more sessions with the Esri team, fantastic sessions. I hope you all to see you tomorrow. Have a nice day, and نشوفكم بكرة.